missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know even the sun sets in paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. We are a summer storm, a feeling you can't ignore. Do you ever stop to feel it caught in the afterglow? I'll come back to your door to know that you believe in summer all that I want. You know, summer we got it all. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. We'll light it up again, the sky and our silhouettes, dancing on the pavement, caught in a
Good morning, ladies and gentlemen. We will start our day in the ballroom in 10 minutes. Thank you.
I least expected. Said you're all that I want. We know together we got it all. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match,
Ladies and gentlemen, our program begins in 5 minutes. Ladies and gentlemen, please take your seats. Our program is about to begin. Thank you. Ladies and gentlemen, please welcome back to the stage your host and co-founder of the AI Engineer Summit, Benjamin Dunphy.
Good morning, good morning, good morning, good morning. How are we doing? We all had fun last night? Is this the crowd that had fun and just came back, or this is the crowd that did not have fun? Looks like some people had too much fun, but thank you so much for coming back for the final day of the AI Engineer World's Fair. So great to see you all. I have 3 minutes and 45 seconds and a couple of announcements to make, so I'd like to get right to it. So I've been talking to a few people, when I get a chance, about the mobile app that we put a lot of effort into, and how it's going to help you with your attendance and interactions at this event. So I wanted to just clear up a couple of things. Number one, the schedule. You can favorite sessions. You can see the session details, favorite them, and you can go to my schedule. So now I can see it there. So for a multi-track event, I just want to make that clear. You can build your own schedule here. So some people didn't get that memo. Of course, you can see all the sponsors. You got the map there. But the real killer feature here is the generative matching and the other networking features here. So I'd like to invite Simon Sturmer on stage, the lead architect for this, just to help explain some features. Can we have a round of applause for Simon, please? So Simon, we got some generative profiles going on here. These look to all be unique for each interaction. Tell me a little bit about what's going on behind the scenes here.
So what we do is we pull in your profile, or we build a profile from your socials and from the questions you answered when you registered, and then we create embeddings from there, and we put that into a vector database, and we do a cosine similarity search and just pull your 5 most similar profiles.
Very nice. And now I'm going to Apoorva's profile, and I can see all her talks there. I can also see some talking points here, and these are generated for me as well.
That's right. So those are while that spinner was going, generated in real time. Yeah.
Awesome. And now if we go to one of her sessions, we can see, after you watch her talk, you can rate it. We got session feedback built in. So this is a fully custom app. But all right, here's the real killer feature that I like. Because when I first came to San Francisco in 2015, I went to a tech conference, and everyone's handing out business cards. So when you meet someone at the event, like, how do you connect with them? Oh, let's exchange emails, right? That's one. Give me your Twitter, your LinkedIn. It's always like different with different people, right? Why don't we get them all right now, Mr. Simon? All right, I'm going to scan your badge. All Boom. Right. Okay, there we go. So we have badge scanning for everyone. Now, I'm connected. As soon as I scan his badge, I get his email. Even if he made it private at first, he can change his settings to make it default to share with me when I scan him. Still got the talking points, the notes, etc. And now he's on my short list of scans. So after the event, I can review all my scans, and I can even export all my connections, which is going to email them to me. So is that pretty cool? What do we think? All right.
Cool. Thanks,
so that's the match. Thank you so much, Simon.
Appreciate it.
For your help on that. Very cool. So that's the app. Just want to make sure we all understand that. The other thing is we have AI engineered jobs. So this is at ai.engineer/jobs. Currently, we're featuring jobs from our Expo partners, so go and check those out if you're looking for your next opportunity. Any Expo partners, if you're not there, please email me and I'll get it up there before end of day. Anyone else want to get some jobs up there, email me and we can talk. Lastly, one more announcement. I got 20 seconds left. We're excited to announce 2025 is now on sale. If you enjoyed your time here, this is the best time to lock in the best rate. So you can go to ai.engineer/2025. or scan that QR code. That's going to reserve your seat, lock in the best rate. And we don't have dates currently locked in, but likely around the same time this year. So that's my time for today. So I'm pleased to welcome to the stage our opening keynote speaker, an absolute legend in this industry. Please join me in welcoming Chris Latner.
All right, good morning, everyone. I'm here to talk to you about modular and accelerating the pace of AI. You know what Gen AI is. I'm not going to tell you all about this. Let me tell you one of the things I think is really cool about it and very different than certain other technologies is that it's super easy to deploy. There's lots of great endpoints out there. There's a lot of good implementations, a lot of ways to make it super easy to build a prototype and get going very quickly. But despite all the availability of all these different endpoints, sometimes you do have other needs. Sometimes you might want to go, and control your data instead of sending your data to somebody else. Sometimes you might want to integrate it into your own security because you've got your critical company data in your model and you don't want to fine-tune it somewhere else. Sometimes you want to customize the model. Like there's research happening all the time, right? A lot of things in building proprietary models that work best for your use cases can make your applications even better. And of course, the inference endpoints are expensive, and so sometimes you want to save money. Sometimes there's hardware out there that's really interesting, and you want to explore out from the mainstream, and you want to go do this. And if you care about any of these things, what you need to do is you need to go beyond the endpoint. And so how do you do that? Well, many of you have explored this, I'm sure. The answer has shifted. It used to be that we had things like PyTorch and TensorFlow and Caffe and things like this, but as inference became more important, the world shifted. First we got Onyx, TensorRT, things like this. And today we have an explosion of these different frameworks, some of which are specific to one model. And that's cool if you care about that one model, but if you have many different things you want to deploy and you want to work with, it's very frustrating to have to switch between all these different technologies. And of course, it's not just the model. You all know there's this gigantic array of different technologies that get used to build real-world things in production. And of course, none of these are really actually designed for Gen AI. So my concern about this, my objection to the status quo is that this fragmentation slows down getting the research and the innovations coming into Gen AI into your products. And I think we've seen so many of these demos. And last year was really the year of the Gen AI demo. But still, we're struggling to get Gen AI into products in an economical and good way. And so whose fault is it? Well, is it our fault? Like, many of you are AI engineers. If you don't, let's sympathize with the plight of the AI engineer. Because y'all, these folks that are building this, have new models and optimizations coming out every week, right? Every product needs to be enhanced with Gen AI. This is not like one thing. We're getting dumped on, and there's so much to do, we can't even keep up. There's no time to deal with new hardware and all the other exciting new features. And of course, once you get something that actually works, the costs end up making it very difficult to scale these things because getting things into production means suddenly you're paying on a per unit basis. So it's not the AI engineer's fault. We should look at the concerns and look at the challenges faced here. And so I think that we need a new approach, right? We've learned so much. Let's look at what we need to do. How do we solve and improve the world here? This is what modular is about. And so I'll give you a quick intro of what we're doing and kind of our approach on this. First of all, who are we? Modular is a fairly young company. We've been around for a couple of years. We have brought together some of the world's experts that built all of these things. And so we've built TensorFlow and PyTorch. We've built compilers like LLVM and MLAR and XLA and all of these different things. And so what I can say about that is that we learned a lot, and I apologize, because we know why it is so frustrating to use all these things, but really the world looked very different 5 years ago. Gen AI didn't exist. It's understandable. We tried really hard, but we've learned. And so what our goal is to make it so you can own your AI. You can own your data. You can control your product. You can deploy where you want to. You can do this and make it much easier than the current systems work today. And so how? Well, what we're doing is really going back to the basics. We're bringing together the best-in-class technologies into one stack, not one solution per model. Our goal is to lift Python developers, PyTorch users. This is where the entire industry is, and so we want to work with existing people. We're not trying to say, hey, ditch everything you know and try something new. We want to gradually teach and give folks new tools so they can be superpowers, so they can have superpowers. And finally, so I spent a lot of time at Apple. I want things that just work. You want to build on top of infrastructure. You do not want to have to be experts in the infrastructure, and this is the way all of this stuff should work, and unfortunately, it's just not the case today in AI. And so at Modular, we're building this technology called Max. I'll explain super fast what this is. Max is two things. One is an AI framework, which I'll spend a bunch of time about. The AI framework is free, widely available. We'll talk about it today. The other is our managed services. This is how Modular makes money, very traditional. We're not going to spend a lot of time talking about that today. And so if you dive into this AI framework, well, we see it as two things. It's the best way to deploy PyTorch. It's also the best way to do Gen AI. And both halves of this are really important. And Max is currently very focused on inference. And so these are areas where PyTorch is challenging at times. This is where Gen AI is driving us crazy with cost and complexity. And so really focusing on this problem is something that we're all about. The other thing, as I said before, is Python. So we natively speak Python. That is where the entire world is. We also have other options, including C++, which we'll talk about later. So how do we approach this? Well, as I said, we work with PyTorch out of the box. You can bring your models, your model works. We can talk to the wide array of PyTorchy things like Onyx and Torch script and Torch compile and all this stuff, and so you can pick your path, and that's all good. If you want to go deeper, you can use native APIs. Native APIs are great if you speak the language of KV caches and page detention and things like this, and you care about pushing the state-of-the-art of LLM and other Gen AI techniques. That's very cool. And also, Max is very different in that it really rebuilds a ton of the stack, which I don't have time to talk about, but we do not build on top of cuDNN and the NVIDIA libraries and on top of the Intel libraries. We replace all that with a single consistent stack, which is a really different approach, and I'll talk about what that means later. And so what you get is you get a whole bunch of technology that you don't have to worry about. And so again, as a next-generation technology, you get a lot of fancy compiler technologies, runtimes, high-performance kernels, all this stuff in the box, and you don't have to worry about it, which is really the point. Now, why would you use Max? So it's an AI framework. You have one, right? And so there are lots of different reasons why people might want to use an alternative thing. For example, developer velocity, your team being more productive. That's actually incredibly important, particularly if you're pushing state-of-the-art. But it's also very hard to quantify. And so I'll do the same thing that kind of people generally do, is go and talk about the quantifiable thing, which is performance. And so I'll give you one example of this. We just shipped a release that has our int4, int6, K fancy quantization approach. This is actually 5x faster than llama.cpp. And so if you're using llama.cpp today in cloud CPUs, this is actually a pretty big deal, and 5x can have a pretty big impact on the actual perceived latency of your product and performance and cost characteristics. And the way this is possible is, again, this combination of really crazy compiler and technology and other stuff underneath the covers, but the fact that you don't have to care about that is actually pretty nice. It's also pretty nice that this isn't just one model. This is, we have this make it easy to do int4 technology, and then we demonstrate it with a model that people are very familiar with. And so if you care about this kind of stuff, this is actually pretty interesting, and it's a next generation approach to a lot of the things that are very familiar, but it's also done in a generalizable way. Now, CPUs are cool, and so so far we've been talking about CPUs, but GPUs are also cool. And what I would say and what I've seen is that the CPUs and AI are kind of well understood, but GPUs are where most of the pain is. And so I'll talk just a little bit about our approach on this. And so first, before I tell you what we're doing, let me tell you our dream. And this is not a small ambition. This is kind of a crazy dream. Imagine a world where you can program a GPU as easily as you can program a CPU in Python. Okay. Not C++, in Python. That is a very different thing than the world is today. Imagine a world in which you can actually get better utilization from the GPUs you're already paying for. I don't know your workload, but you're probably somewhere between 30%, maybe 50% utilization, which means you're paying for like 2 to 3 times the amount of GPU that you should be. Right? And that is understandable given the technology today, but that's not great for lots of obvious reasons. Imagine a world where you have the full power of CUDA. So you don't have to say there's a powerful thing and there's an easy-to-use thing. You can have one technology stack that scales. Well, this is something that is really hard. This is something where NVIDIA has a lot of very good software people, and they've been working on this for 15 years. But I don't know about you. I don't run 15-year software on my cell phone. Like, it doesn't run BlackBerry software either. And I think that it's time to really rethink this technology stack and push the world forward. And that's what we're trying to do. And so how does it work? Well, it's just like PyTorch. You use one line of code and switch out CPU to GPU. Haha, we've all seen this, right? This doesn't say anything. I actually hate this kind of a demo because the way this is usually implemented is by having a big fork at the top of 2 completely different technology stacks, one built on top of Intel MKL, one built on top of CUDA. And so as a consequence, nothing actually works the same except for the thing on the slide. And so what Modular's done here is we've gone down and said, let's replace that entire layer of technology. Let's replace the matrix multiplications. Let's replace the fused attention layers. Let's replace the graph thingies. Let's replace all this kind of stuff, and then make it work super easily, super predictably, and let's make it all stitched together. And yeah, it looks fine on a slide, but the slide is missing the point. So if you are an advanced developer, and so many of you don't want to know about this, and that's cool. If you are an advanced developer, like I said, you get the full power of CUDA. And so if you want, you can go write custom kernels directly against Macs, and that's great. And for advanced developers, which I'm not going to dive too deeply into, it's way easier to use than things like the Triton language and things like this, and it has good developer tools, and it has all the things that you'd expect from a world-class implementation of GPU programming technology. For people who don't want to write kernels, you also get a very fancy auto-fusing compiler and things like this, and so you get good performance for the normal cases without having to write the hand-fused kernels, which is, again, a major usability improvement. Now, it's cool. Like, there's a lot of things out there that promise to be easy, but what about performance? Right? A lot of the reason to use the GPU in the first place is about performance. And so one of the things that I think is pretty cool, and one of the things that's very important to Modular, is that we're not comparing against low standards. We're comparing against the vendor's best. In this case, NVIDIA, they're experts in their architecture. And so if you go look at, again, there's a million ways to measure things, a micro benchmark. Go look at the core operation within a neural network, matrix multiplication. This is the most important thing for a wide variety of workloads, and again, one set of data. But we compare against cuBLAS, the hard-coded thing, and then also against Cutlass, the more programmable C++y thing. And so Max is meeting and beating both of these, by just a little bit. I mean, it's, it depends on your bar, and data is complicated. But if you're winning by 30%, 30% is actually a pretty big deal given the amount of cost, the amount of complexity, the amount of effort that goes into these kinds of things. And so I've talked a lot about the what, but I haven't talked about the how. And so the how is actually a very important part of this, and I'll just give you a sample in this. So we are crazy enough that we decided to go rebuild the world's first AI stack from the bottom up for Gen AI. And as part of doing that, what we realized is we had to go even deeper. And so we built a programming language. We have a new programming language. It's called Mojo. And so the thing about Mojo is if you don't want to know about Mojo, you don't have to use Mojo. You can just use Max. It's fine. But we had to build Mojo in order to build Max. And I'll tell you just a couple of things about this. Our goal is that Mojo is the best way to extend Python. And that means that you can get out of C, C++, and Rust. And so what is it as a programming language? It's Pythonic, so it looks like Python, it feels like Python. Everything you know about Python comes over, and you can not have to retrain everything, which is a really big deal. You get a full tool chain. You can download it on your computer. You can use it in Visual Studio Code. It's open source, available on Linux, Mac, Windows. 200,000 people, 20,000 people in Discord. It's really cool. Would love for you to go check it out if you're interested in this. But what is Mojo? what actually is it? Fine, there's a programming language thing going on. Well, what we decided is the AI needs two things. It needs everything that's amazing about Python. This is, in my opinion, the developers. This is the ecosystem. This is the libraries. This is the community. This is even, the package managing, and like all the things that people are used to using already. Those are the things that are great about Python. But what is not great about Python, unfortunately, is its implementation. And so what we've done is we've combined the things that are great about Python with some very fancy, highfalutin compilery stuff, MLAR, all this good stuff, that then allows us to build something really special. And so while it looks like Python, please do forget everything you know about Python, because this is a different beast. And I'm not going to give you a full hour-long presentation on Mojo, but I'll give you one example of why it's a different beast, and I'll pull it back to something many of you care about, which is performance. And what I'll say is that Mojo is fast. How fast? Well, it depends. Like, this isn't a slightly faster Python. This is a working back from the speed of light of hardware kind of system. And so many people out there have found that it's 100 times to 1,000 times faster. In crazy cases, it can be even better than that. But the speed is not the point. The point is what it means. And so in Python, for example, you should never write a for loop. Python is not designed for writing for loops if you care about performance, at least. In Mojo, you can go write code that does arbitrary things. This is an example pulled from our Llama 3, written in Mojo that does tokenization using a standard algorithm. It's chasing linked lists, has if statements, for loops, like it's just normal code. And it's Python. I mean, it feels like Python. And that is really the point. And so for you, the benefit of Mojo is, first of all, you can ignore it if you don't want to care about it. But if you do, you don't have to learn C, C++. You have lower cost by default versus Python because performance is cost. It means that as a researcher, if you use this, you can actually have full stack hackability. And if you're a manager, it means that you don't have to have people that know Rust on your team and C++ and things like this. You can have a much more coherent engineering structure where you're able to scale into the problem no matter where it is. And so if you want to see something super polarizing, go check the modular blog, and we'll explain how it's actually faster than Rust, which many people consider to be the gold standard, even though it's, again, a 15-year-old language. So I have to wrap things up. They'll get mad at me if I go over. The thing that I'm here to say is that many of you may want to go beyond the API. And they're fantastic. There's amazing technology out there. I'm very excited about them too. But if you care about control over your data, you want to integrate into your security, you want customization, you want to save money, you want portability across hardware, then you need to get on to something else. And so if you're interested in these things, then Max can be very interesting to you. Max is free. You can download it today. It's totally available. You go nuts. We didn't talk about production or deployment or things like this, but if you want to do that, we can also help. We support production deployment on Kubernetes, SageMaker, and we can make it super easy for you. Our GPU support, like I said, is actually really hard. We're working really hard on this. We want to do this right, and so it'll launch officially in September. If you join our Discord, you can get early access, and we'd be very happy to work with you ahead of that, too. We're cranking out new stuff all the time. And so if you are interested in learning more, you can check out modular.com, find us on GitHub. A lot of this is open source, and join our Discord. Thank you, everyone.
Ladies and gentlemen, please welcome to the stage Principal Developer Advocate of AWS, Auntie Aart.
Hi, everyone. I'm so excited to be part of this conference and share with you 5 practical steps from software developer to AI engineer. And if anyone is wondering here, this avatar on the slide, this is what happens if you ask AI to make you look a little bit more agentic. All right, let's get started. So I'm pretty sure everyone is familiar with this image here and the post from Swix that defines the new role of the AI engineer. And as you've experienced probably daily in your jobs, you don't need to be a full ML researcher anymore or data scientist. things that took months or years before to get AI projects into production is now able to be in just a couple of API calls. Super exciting. But still, if you're working with AI, it still makes sense to understand the basics of the technology. And this involves a couple of things, right? So you have to understand at a basic level how foundation models work, why they're sometimes producing output that you don't expect in your application code, right? You have to understand how you can customize the models, how you can, for example, sometimes fine-tune models to adapt them to your specific use cases and data sets, how to include functions in your application code to give them access to additional systems. The good news is, if you're just starting on this journey to become an AI engineer, there's plenty of resources now these days available to you to learn. And I wanted to call out one specific course here, which is called Generative AI with Large Language Models. A few colleagues of mine, we actually collaborated with Andrew Ng and the team at deeplearning.ai to put this course together and help you understand the fundamentals of generative AI to help you build real-world applications. If you're curious, it's available on deeplearning.ai and on Coursera. Now, the second step in this journey is to get hands-on with the AI developer tools to help you increase your productivity. And I think we all seen this quote here, and we experienced it in our daily jobs, that how we do work, how we develop applications has changed a lot. These days, we can literally use natural language inputs to interact with applications, and really, English has become one of the most popular and hottest programming languages. I think we can see this happening. For example, you can go these days from English to code by asking AI to, for example, rewrite a README file. We can also do code to English. For example, asking AI to document functions in our code. But this is not all. If we look at the software development lifecycle, I think many of us can agree that the majority of time we usually spend not writing valuable code, but all the other things around it. So sometimes up to 70% of unvaluable tasks, which is writing boilerplate code, writing documentation, trying to maintain old code bases, right? And sometimes we only have like a fraction of the time, maybe 30%, that we're spending on actually what, creates joy in kind of the creative tasks in software development. And this is what led us at AWS, this inspired us to create Amazon Q. Amazon Q is a generative AI-powered assistant specifically developed for software development. And this is much more than just a coding assistant. Q Developer actually uses agents to perform much more complex tasks and help you automate those. For example, feature development and also code transformation. Think about working with old Java-based code bases that you need to migrate maybe to a newer Java version. And to show you how this works, I asked my colleague, Mike Chambers, to put together a quick demo. Let's have a look.
With Amazon Q installed inside of my IDE, I can go to New Tab, and I can start a conversation with Amazon Q Developer. And I can do the kinds of things that maybe you'd expect, such as, how can I create a serverless application, and how do I get started? And the chat session brings back a list of instructions of what I should do, starting off by installing AWS SAM CLI, how to do that, where to get that from, and how to step through the creation of a project. Now, if I've done that, then Serverless SAM, for example, might actually come back with some generated code. And here is that code. Maybe I don't quite know what this code does, so I can right-click on the code and send it to Amazon Q, asking Amazon Q to explain. And the code then will go into a prompt along with explain and generate an answer. And this is great for code that's been generated for us, but also imagine code for legacy systems, something that was worked on years ago by somebody else, where you can get Amazon Q to help explain it. We can also get Amazon Q to generate code. Now this is, again, probably the kind of thing you'd expect. I can put in a comment line inside of my code. In this case, I want to create an input checking function. I'm going to give it some more definition here that I actually want it to trim any string that's being sent into this function. And yes, Amazon Q can generate this small function. Well, that's great. But what about if I've got more code that I need to have generated? Well, I can go to the chat and put in /dev, and I can put in a much more comprehensive description of something that I would like. In this particular case, I'm going to ask for it to write a function to search by category in DynamoDB with a bunch of details about the way that I want the output to be formatted. So this is much more than just a single or a few lines of code. And in this particular case, what's going to happen is it will come back again with a step-by-step list of what's required. So I need to add in template.yaml. It's recommending that I create search by category.mjs and many more things. But this isn't just a big shopping list of things that I need to do. This is actually a plan, and it's a plan that Amazon Q can actually follow for us. So it generates some code as a change set, something that we can look at the difference between our current code and what it suggests. And if we like that, we can actually click on the Insert Code button, and it will add all of that code into our project. Way more than just a couple of lines. So Amazon Q Developer is much more than just code completion.
All right, if you're curious to learn more about Amazon Q Developer, we have a couple of more sessions throughout this day. So make sure you're checking those expo sessions, and we also do have a session at our AWS booth here. You can also visit our Amazon Q Developer Center for much more examples what you can do with it. All right, let's come to step 3, and this is where the fun starts. Start prototyping and building with AI. And the fun includes a couple of steps, right? Everyone developing with AI knows this. It starts all with defining your use case, and then really you're on this road trying to choose from different models. You're trying to, customize them to your use case, decide whether it's prompt engineering, whether you do RAG, whether you need to do a little bit of fine-tuning there with your data. And of course, across the whole development workflow, you have to incorporate responsible AI policies, making sure data is private and secure, and also implementing guardrails into your application. And then when you're integrated, another fun part, obviously, working with the agents, what we're hearing a lot here throughout this conference, and the fun topic of, how to keep them up to date. GenAI ops, I think there's a lot of terms for that, MFM ops, LLM ops. So really kind of a lot of things to consider here. I want to dive in briefly into the topic of models to choose. And this is really an important topic. When you're evaluating models, you have to really evaluate them thoroughly, because most likely there's not just going to be one size fits all for you. In fact, if you look at all your use cases you want to implement, there's likely no one model to rule them all. And this is why we developed Amazon Bedrock. Bedrock is a fully managed service that gives you access to a wide range of leading foundation models that you can start experimenting with, implementing into your applications. It also integrates the tooling you need to customize your model, whether it's fine-tuning, also to include RAG workflows, to build agents, and of course, everything in a secure environment where you are in full control of your data. And speaking of choice, just to give you a quick overview, as of today, this is the selection of models you can choose from. We're working with leading companies such as AI21 Labs, Anthropic, Cohere, Meta, Mistral AI, Stability AI, and we also offer our own Amazon Titan models for you to choose from. And I'm super excited just to call this out. Last week, together with Anthropic's launch, we integrated Claude 3.5 Sonet on Amazon Bedrock as well. So you can also, since last week, use this model. Super exciting. Now, with choice also comes responsibility, right? And we continuously innovate and trying to make it easier for you to build applications across the different model types. And just a few weeks ago, we introduced a new unified Converse API in Amazon Bedrock. What does this do? The unified Converse API helps you with a new unified message structured invocation, meaning you can use the same parameters and bodies regardless of which model you choose. And we are on the platform side, we're handling this translation if parameters are called different for the different models, handling the system user assistant prompts for you, and also giving you a consistent output format. And as well having native function calling support in here. But let me show you how this looks in code. So here's the Python example that shows how you can use the new API. This is Python, so we're starting by just integrating the Python SDK client here, and then you can define this list of messages. And here's, for example, where you put in your user message prompts, you can put in system prompts as well, and then this message list you can just pass in this single API call using the Converse API here. In the model ID, you can choose which model you want to test. Here I'm using an Anthropic model, and then pass the messages and also the inference parameters. And again, in this API, all those parameters are standardized, and we're going to make the work behind the covers to convert this to the specific format that the model is expecting. So you have an easy way to work across different models. Similarly here for function calling, we do have the support built in that with the models that support it. So how we implement this is by defining a tool list. So tool here equivalent to the functions you want to give access to. And then when you're doing the Converse API call, you can pass this list of tools. All right, if you want to find out more about Converse API, here's a link to our generative AI space on community.aws, which has a lot more tutorials, code examples, not just for Python, but across different languages as well. So check it out. The author here, Dennis Traub, is also somewhere here in the audience here this week. So if you want to connect with him, talk about different code examples and how to use the API, feel free to reach out. All right, now let's integrate AI into our applications. And this can be a whole session in its own, but I want to focus on one of the hottest topics right now that we're discussing during the conference, which is, of course, agents. And I have one more demo here, and I asked my colleague Mike last time to put together an exciting demo to show you what you can do with agents. Mike? And we need sound.
To be able to create agentic workflows right inside of the AWS console and inside of the service. It works fully serverless, and I've used it to create an agent that plays Minecraft. Let me show you how I did it. If we jump into the AWS console, go down the menu on the left-hand side to agents, you can see the agent screen here, and I can open up my agent, my Minecraft agent. Now, if I just go into Agent Builder and just expand the screen out a little bit, you get to see some of the parameters that I used to create this agent. So you can see the large language model I used, in this case Claude 3 Haiku, and you can also see this, the instructions for the agent. Now, this is not some notes for myself. This is actually prompt engineering that we're doing to explain how we want the agent, in this case the Minecraft bot, to play the game. And then we also have to add some tools in, right? Some Minecraft tools. So we do that through actions and inside of action groups. So I've got a couple of different action groups. We've got Minecraft actions and Minecraft experimental. Let's have a look at actions. And inside of here, we can see some really simple things, some actions that the bot will be able to do. And these are all linked up to code. So we've got the action to jump. we've got the action to dig. And you can see the description here for action to dig. It's got some instructions. Again, this is prompt engineering. And then we've got some parameters that we can collect. In fact, we require these parameters, so the bot needs to get these for us. If I scroll down a little further, there's a couple of really simple actions in here. Action to get a player location and action to move to a location. I want to show you those in action because the bot can actually problem solve and reason its way to be able to use these tools to solve simple problems. Let's jump into the game. And so it is nighttime, so let's set it to be the daytime so that we can see what's going on. So set time to day. Okay, and there in the middle of the screen you can see Rocky. Rocky is the Bedrock agent running inside of the game. And we can talk to it and we can have a chat session, but what about if we want it to come to us? Now there is no tool to come to us. So I'm just going to back up a little bit further, make it a little bit more of a challenge, and I'm going to say come to me in chat. And what's going to happen now is that the agent's going to reason through a whole set of actions. It's going to look to see who requested that. It's then going to take that name, and that's my name, and it's going to find the location of that player, and then it's going to map a path from where it currently was to me. All of those things happened all in that blink of an eye, and there's agentic workflows making all of that happen. This is super exciting. I'm discovering new things that this bot can do every day. But with that, it's back to you.
All right, thank you, Mike. If you're curious to know how we did this, check out our booth session. We're running the demo there as well. And we have another session in the agents track later today, so make sure you're popping in there if you want to know more. And, of course, you can find the project code for this on GitHub, so if you want to play it on your own in how you can integrate agents into a fun thing, check out this project. All right, we're almost there, so the last step I really want to call out is stay up to date. There's so much happening in this space, as you all know, and a really good way to do that is to engage with the community. Speaking of community, I have one last announcement to make, and I'm super excited to announce that we're transforming our AWS loft here in San Francisco into the AI engineering hub for the community. So we're super excited to host workshops, events, and meetups there. If you want to suggest a couple of topics you're most interested in to make those events most valuable to you, fill out this quick survey here. Also, if you're interested in speaking or hosting a meetup yourself, you can let us know. And also, we do have another event tonight, which I think we're reaching capacity or just half reached capacity, but we do have a happy hour with Anthropic tonight at the Loft. In case you didn't make it anymore and we're at capacity, don't worry. We're working on putting together much more events like this in the upcoming weeks and months. So keep an eye out for those. And with that, I'm coming to the end of my presentation. This wraps it up, the 5 practical steps to become an AI engineer. And let's innovate together. And I'm looking forward and I'm excited to see what you build with AI. Thanks so much. Make sure you're checking out the rest of the sessions here and also pop by our booth outside. Thanks so much.
Relations at Anthropic, Alex Albert.
All right. Morning, everyone. So today, I want to start with a little story. A short history lesson, if you will. So, sit back, get comfortable. I'm going to take us back to the year 1882. It's the dawn of the electrical revolution, really. The world's first commercial power plant just opened up. Electricity, this amazing new force, is all the rage in the manufacturing industry. People are claiming that it's going to change everything. And yet, something very interesting happened around this time. Or rather, it didn't happen. You see, despite electricity's obvious superiority in comparison to the traditional techniques at the time, like steam engines, it didn't immediately improve manufacturing productivity. Why? Well, because factory owners were simply trying to replace their old technology with this new technology into an outdated paradigm. Let's picture a typical factory at the time. So we have a huge coal-fired steam engine on one end, and we have a network of transmission lines going across the top, all driving hundreds of machines locked in the same rhythm. These legacy steam power factories were incredibly inefficient. You know, if one station needed power, all of a sudden you had to turn on that entire steam engine and it had to power all of them. Factory layouts were dictated by the limitations of the transmission lines, not by what was best for the process or for the workers. When electricity arrived, many factory owners simply swapped out the steam engine for an electric one. And sure, you know, they added some lights and, you know, workers didn't have to toil next to a coal-fired furnace all day, but the fundamental limitations of the factory remained. So this real electrical revolution, well, it didn't actually come until we imagined factories from the ground up, with electricity at its core. Factories started to become flexible and adaptable. They allowed for smaller, specialized tools. Workers could bring their tools to the items instead of having to lug the items back to their workstations. The entire manufacturing process became more efficient, more humane, and more productive. Now, let's fast forward 140-something years to today, and you can see that we find ourselves at a similar point in regards to AI and LLMs. Enterprises, startups, developers are all building and integrating LLMs into their products, but often they're just tacking it onto their existing product surface, adding a few star icon buttons in the top left corner, and calling it a day. And this is not the first time we've seen this in Silicon Valley. Let's think back to when mobile first emerged, right? Companies simply tried to just shrink down their website and put it on a phone. It wasn't until we redesigned apps from the ground up with the unique capabilities of mobile, like always-on camera and GPS, that we actually began to see true innovation in the space and adoption. This is when the Snapchats and the Ubers of the world started to emerge. So just as companies and just as factories went through their, replace steam engines with electric one phase, and tech companies went through their just hire a couple mobile web dev people phase, we're now in our magic star icon phase with respect to AI. And it's funny, but the thing is, you can't blame any of the companies or developers that are actually trying to do this right now, right? Like, all of us are trying to do this, but in many ways, we're just still so early. LLMs are non-deterministic. They're hard to build on. They're completely different than what most developers are used to using. Reliability is still an issue. Prompts still take rounds and rounds of optimization. And we've also just started to scratch the surface of potential product opportunities. So far, not much has really stuck beyond just the text box. We've been missing something that's a little hard to put a finger on. But just last week, I think we scratched the surface of a potential new product feature that we can build. As some of you may have heard, last Thursday we released our new model, Claude 3.5 Sonet. 3.5 Sonet is the first model that we released in the new Claude 3.5 family. It's only the middle model, and yet it is better than our last best model, Claude 3 Opus. In my opinion, Claude 3.5 Sonet is one of the best models in the world right now, and the benchmarks seem to back it up. MMLU, human eval, GPQA, tool use, all the common characters here. It's top of its class in many regards in these academic lab-type environments, but what I am most excited for is how it actually does in the real world. The model is particularly strong in RAG use cases thanks to its 200K context, and also has near-perfect recall over that entire context as well. On coding tasks, 3.5 Sonet seems to grasp debugging problems better. It's not getting stuck in those same loops as much as previous models. One of the best methods that we found for actually measuring more complicated chains of reasoning is pull requests. They have a defined task, they usually take a few steps to solve, and the model is able to iteratively write and test its way to a solution. In our own internal pull request evals, we're seeing that Claude 3.5 Sonet scores a 64%. And to put that number in comparison, Claude 3 Opus only scored a 38%. 3.5 Sonnet also has state-of-the-art vision abilities. It shows considerable improvement over 3 Opus in basically every benchmark that we tested it on. Things like table transcriptions and OCR are a breeze now. Passed this table in 3.5 Sonnet and basically replicated it perfectly in Markdown. Probably can't read all those numbers, but trust me, I double-checked them to make sure they're all right. Vision capabilities were actually what amazed me the most when I started playing around with this model. It feels like we are really on the cutting edge of unlocking so many more use cases. And as you're hearing me say all this, you might be thinking, well, that's great, Alex, but I mean, it doesn't mean anything if I can't actually use the model. And you're right, and we heard you. And that's why 3.5 Sonnet is available on our API, AWS Bedrock, and Vertex AI. We understand that developers want choice when they're building, and we want Claude to be available wherever you are. In terms of pricing, 3.5 Sonnet is 5 times cheaper than 3 Opus. It's only $3 per million input tokens and $15 per million output tokens. 3.5 Sonnet's combo of speed, intelligence, and low cost makes it much more economical to use and embed in your apps than 3 Opus. But 3.5 Sonnet is not all that we've released in the past week. We also released a new product feature that I think is actually more inspiring to developers in terms of thinking about and building those AI products from the ground up. It's called Artifacts. Artifacts separate the content that Claude produces from the actual chat dialogue itself. This allows you to work collaboratively with Claude on things from essays to SVGs to React websites. Artifacts become really powerful when you combine it with 3.5 Sonnet. Those coding skills plus that reasoning ability plus that strong visual acuity enables a new product experience that's really fun to use. It's also a developer's best friend in that it allows you to quickly take screenshots and Figma diagrams and quickly turn it into code and components that you can actually just go use. As you can see in this, I basically cloned our entire Claude AI chat layout in React just from a single screenshot. And this feature has practically been hiding in plain sight now, just waiting really to be discovered for over a year and a half. Maybe this tweet is right, and we really are early on this S-curve of productionizing LLMs, which I think is actually pretty inspiring. And Artifacts is not the only AI feature that we launched recently. On Tuesday, we released Projects. Projects enables dev teams to work and collaborate much more efficiently by grounding Claude's outputs in your own knowledge, whether it's style guides or code bases or transcripts or even your past work. On our Claude team plan, you can even share these projects in your chats with all your teammates. At Anthropic, our engineers now upload code repos and documentation that they use, and I've started to see people actually just share the chats and the artifacts instead of Google Docs or site documentation. Projects is another great example of when you think from an LLM and an AI standpoint first, you can actually start to build product experiences that complement these technologies and don't feel like a simple add-on to what you already have. So now that hopefully the creative product juices are flowing in everyone's minds, I want to dive a little bit into API improvements that we've rolled out recently and things that allow you to actually build this cool stuff. I also want to give a preview of what's coming next that will enable you to build even more. So a month ago, we released our new Tool Use API. Tool Use allows you to give Claude custom client-side functions that it can then intelligently leverage. Tool Use also enables things like consistent structured JSON output. With 3.5 Sonnet, I've actually started to see devs give Claude hundreds of tools at a time. On the developer console front, we're also continuing to iterate. We added a prompt generator that uses Claude to write prompts for you based on a task description. So you can see in this video, we put in a task description, and then out comes a optimized prompt. And then once that prompt is all done, you can actually just start editing it right in the workbench itself. You can see we've also added support for variables, so you can edit prompt templates as well, test things like RAG use cases. And finally, we're also working on a new evaluate feature, which is currently in console right now with a beta tag, and we will plan to share more on this and continue to iterate on it very soon. So what else is next? Well, there's two things that I can share right now. First is that you can expect more models. 3.5 Haiku and 3.5 Opus are coming later this year. With each model generation, we're looking to increase the intelligence, decrease the latency, and decrease the cost. The number one thing that I tell developers is to not forget to build with that in mind. Models will become smarter, cheaper, and faster in orders of months, not years. When you're planning your product roadmap, be ambitious enough to build with the belief that new models may arrive during your development period. We are also working on other areas of research like interpretability. In one of our latest papers called Scaling Monosemanticity, we explained how we've been able to find features within models that activate for different topics. Once you identify a feature, you're able to clamp its value and turn it up or down to actually steer the model's outputs. A few weeks ago, we showed Claude.ai users how this worked through Golden Gate Claude, which was a version of Claude that had the Golden Gate Bridge feature turned up significantly. Yeah, fan favorite. We currently have a few beta testers also experimenting with a steering API. This allows developers to find and clamp features for specific attributes and actually turn that dial up or down, which again allows you to control Claude's outputs in addition to actually just prompting it. We hope to be able to roll this out to more developers in the very near future as well. Now, if anything in this talk has sparked any ideas, I want to encourage you guys to just go out there and build and make quick prototypes as fast as you can to get that validation and that feedback loop started. And for even more of an incentive, we actually just launched another Build with Claude contest yesterday. It runs until July 10th. The top 3 projects will each receive 10K in Anthropic API credits. To see more details, just visit that link below. It's just at the top of our docs page as well, so you can find it there too. I'll leave that up for a second. And finally, if you have any questions or you want to hear more about just what we're thinking about, I'll be at that AWS booth down the hall for the next few hours. You can also find me on X/Twitter at AlexAlbert with 2 underscores. I do try to read all my DMs. I spend way too much time on that site, so feel free to ask questions there as well. And with that, I want to say thank you guys very much and enjoy the last day of the summit.
Ladies and gentlemen, please welcome to the stage CEO of LangChain, Harrison Chase.
Hello. Today, I want to talk about agents. So LLM-powered agents are really nothing new. The React paper came out in October of 2022. LangChain launched about a month after that. And AutoGPT is over a year old. And to me, AutoGPT represents the peak of hype in agents. And I actually think for a few months after that, there was a bit of a fall off in interest as people realized that the generic agent architecture wasn't reliable enough to build systems to ship to production. While there was this fall off, I do think there was some really interesting work being done. So OpenAI's Assistance API, I think, was really novel in a few regards, and I'll come back to that in a little bit. And earlier this year, we launched LangGraph. While LangChain did agents, it also did a bunch of other things. LangGraph is purpose-built for agents, however. What exactly does that mean? So LangGraph is highly controllable and low level. As mentioned, we saw that these generic agent architectures weren't reliable enough, and that companies that were shipping agents to production were building custom cognitive architectures, encoding little differences in how they wanted their agents to behave. And this was super important. And so we made LangGraph extremely low level and controllable. It also comes with a built-in persistence layer, which enables a lot of really cool human-in-the-loop interaction patterns. And it's streaming first, because streaming is really important for LLM UIs. And just to emphasize, LangGraph works with or without LangChain, and it integrates seamlessly with LangSmith, our testing and observability platform. LangGraph's already being used in production by a lot of our awesome partners, ranging from cutting-edge open source projects like GPT Researcher, to trailblazing unicorns like Replit, to public companies innovating at scale like Norwegian Cruise Line, Ally Bank, and Elastic. And today we're excited to announce the first stable version of LangGraph, reaffirming our commitment to building an agent architecture that allows you to build the custom cognitive architectures that are necessary for bringing agents to production. But that's not the only thing we're launching. So I want to go back to the Assistance API, which I mentioned earlier. And I think there were a lot of really cool things here and really novel things. It wasn't a framework. It wasn't just a framework for building agents. It also introduced infrastructure components. It had built-in persistence. It kept track of the messages and stored them for you so you didn't have to do that. It had this concept of background runs, really good for longer running asynchronous workloads. And it allowed you to configure agents. The downside is that it didn't give you full control over the cognitive architecture of your application. It came with a specific state that it expected your application to have, a list of messages, and it was a little bit rigid and didn't let you easily do other things besides that. And so that got us thinking, what if we took LangGraph, which lets you build these custom cognitive architectures, and combined it with these generic agent infrastructure pieces? Today, we're excited to announce LangGraph Cloud, which is a step in that direction. So with LangGraph Cloud, you can take your LangGraph applications written in Python or JavaScript code, and with no changes, get a production-ready agent API. That agent API has all the benefits of the Assistance API. So it comes with built-in persistence for whatever the state of your LangGraph agent is. It comes with a task queue to manage background runs, and you can configure different instances of your graph to change out the LLM or prompt that's used. But we've also added a few other things that we're really excited about. So when you kick off an agent run and you send a message and it goes and it does a bunch of work, what happens when you send it another message before it's finished? We call this double texting, and we've introduced 4 different modes to handle this. Agents aren't just invoked through chat. They're also triggered on schedules, and LangGraph Cloud comes with built-in cron jobs to easily support this. I talked about human in the loop. One of the really important human in the loop features that we're seeing is the ability to break before specific steps. For example, if you have a tool that you really want the user to approve access for. So LangGraph Cloud easily comes with breakpoints, which allows you to add this and then resume once you get that confirmation. That's not the only human in the loop feature that's supported. So with LangGraph Cloud and the built-in persistence, you can easily go back to any step in the agent's trajectory, edit that, and then resume from there. And so this is supporting a bunch of really cool time travel-like features that we think will be very important for the UXs of the future. And just to emphasize, another benefit of LangGraph Cloud, of course, is that it's not bound to OpenAI, and it supports any cognitive architecture that you can build with LangGraph. Finally, I want to talk about LangGraph Studio. So LangGraph Studio is what we think the best way to build, debug, and share agents is. So taking a look at this video, you can see that you can easily see the graph of the agent. You can invoke it. You get streaming output of all the steps and the tokens. You can go back. You can modify steps, edit it, and resume from there. You can also add breakpoints so that for future iterations, you have to explicitly approve it before you continue. So all those human-in-the-loop features that I mentioned, we built into LangGraph Studio and are providing a developer experience specifically aimed for building agents. So LangGraph Cloud is in private beta. We're excited to work with cutting-edge companies to figure out how to deploy agents reliably. We think a framework like LangGraph that gives you complete control over the cognitive architecture of your application is just one part, and we strongly believe that everyone should be building that. That is business logic that you should be incorporating, and that is your moat in some sense. However, we also think there are generic infrastructure pieces that just slow down the time to get to production, and that's what we want to be building with LangGraph Cloud. Thank you all.
All right. How do we enjoy the opening keynotes? Yeah? Really great time. I want to run through a couple of the tracks coming up, so we can go through that. So, agents. So Andrew Ng famously said that AI agents could drive more progress in 2024, even more than the next generation of frontier models. Our host, Demetrios, from the MLOps community, just came off organizing his own AI quality conference next door and brought his ukulele to guide us through building crews and factories and AI agents. Join him in salons 14 to 15, and to get there, head to the AWS booth down there and turn right at the end of the hallway to the end. Evals and LLM ops. AI engineers should build real moats instead of GPT-4 wrappers. Twitter loves hacky MVPs, but serious AI engineering means writing great evals and building good operational discipline for you to ship better, faster, and cheaper. You might think our track sponsor, Galileo AI, ships a UI generation platform, but you might be surprised by how they ship the evals that ship the platform. So, mouthful to say. This is Swix's copy. I'm reading it for the first time. So join Osman in salons 2 to 6, just outside the doors behind you and to the left. At our summit last year, OpenAI launched the Year of Multimodal AI with vision and image generation. This year, GPT-4o is just one of many frontier models we will use to push into applications for on-device vision, real-time TTS, character simulation, and classroom education. One of the track speakers, Ben Hilac, worked on AI and the Apple Vision Pro, and his co-founder, Alexis, will guide us through the dawn of multimodality. Join her right here in Salon 7. An AI engineer is a convention of both GPU-rich and poor, and we are excited to learn the state-of-the-art from people making it. Didn't get a chance to rehearse this. This is going well. Our host, Nyla, worked in product at NVIDIA and Convey, and is excited to accelerate our learning at the top teams in GPUs and inference. Due to scheduling conflicts, we also have 2 talks here from yesterday's tracks. Scott Wu from Cognition, a.k.a. Devin, on CodeGen, and Kathleen Keneally of Google Gemma on open models. Join Nyla and her speakers right here in Salon 8. And last but not least, day 2 of the AI leadership track addresses more needs of VPs of AI, from understanding enterprise RAG, building evals and security, privacy, and compliance safeguards, hiring and growing an AI engineering org, as well as case studies from Cohere and Twilio. And as a reminder, this track is exclusive to AI leadership track attendees with the green lanyards and the green badges. So if there is room at session start time, we can let in speakers with the blue badge and blue lanyards. But anyone else, again, please do not attempt to attend these sessions. These are exclusive sessions, or you'll be escorted off the premises by security. Please don't make us do that. If you want to attend these sessions next year, the ticket's there for you to purchase. So these take place right across the hall in salons B to D. So we have a number of things happening after this block of talks. We got Expo and Expo sessions from 10:30 to 11:10. We got breakout tracks from 11:15 to 12:15. Then we'll have lunch. We got Expo and Expo sessions happening more. Then we have HF0. They're doing a demo day That's going to be in salons 2 to 7 over there, just outside the doors. And then we got the more expo sessions. Then we'll be back here for closing keynotes from 4 to 5. That includes CEO of GitHub, Thomas Domke. But I believe if the demo gods are good, we might actually have a special guest with us today. Tim, did we get that set up? Oh, hey, hello. Who's this?
Hey, what's going on?
Everyone, please, come on, welcome Swix.
Hey, from Singapore.
This is a live
crew here is also watching along. It is 1:13 a.m. our time.
Right on. Well, glad you could join us, Swix. So, how's it been? What's going on? Do we want to give any more context to the folks here?
Scheduling speakers is hard, especially when they're busy launching Gemma 2. And it's been a fun experience putting this together. I hope everyone's having fun. I hope that the talks have been engaging. I wish I was there with you.
We absolutely miss you. I know a lot of people thought it was a joke for a long time that you didn't get to make it. So I'm really glad that you're supporting us. This guy has been so helpful in everything. Like all the sessions that you see here, he's curating that with help from his friends. But what is it like from afar? Watching the live stream. Like, do you have time to watch the live stream? Are you catching any of the talks?
Yeah. If actually people are watching the YouTube live stream, that's me in the chat, just hanging out with folks, saying things I regret sometimes. But it's very fun to just be one of the audience. My dream was always to actually just show up at one of these conferences and just be an attendee and not know what's going on. I think there's a little bit too much not knowing what's going on even as a co-organizer right now. But it's been fun nonetheless.
I think the lessons learned from this event will allow us to implement a lot of procedures and policies that allow us to smooth the organization tasks a bit. And I think well, we might have a little bit more budget now that we've kind of proven the model here. So any parting thoughts as we enter the last day?
Yeah, I mean, there's lots of amazing talks. I'm personally excited about I can't pick favorite. I'm personally excited about all of them, and I'll catch up on live stream afterwards. And I think there's some after parties as well, right? I'm not sure what the social schedule is like, but there's tons of after parties.
I think they're all they should be all on the homepage. The homepage is getting very long now at this point.
Yeah.
Let's put those in Slack. Is everyone on Slack? Let's drop those in Slack as well. So we'll drop those in the announcements or general.
Yeah, and I think I've restored for World's Fair 2025. I broke it just before you went on stage because I told you I was going to change the URL and then we didn't change the QR code. So try it again.
That's why it broke.
Yeah.
I thought it was our QR provider that just got a spike
No.
and they just cut it off. Interesting.
No, it's me.
Swix is to blame for the demo gods. Swix is the demo demon. All right. Well, thank you so much for showing up. So sad that you couldn't be here with us, but really great to be a partner with you at this event. So let's hear it first, Swix, everyone. So we're going to go to break now. We will see you all back here at 4 p.m., but enjoy the breakouts. Until then, see ya.
Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna, don't you wanna? Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. We are a summer storm, a feeling you can't ignore. Do you ever stop to feel it caught in the afterglow? I'll come back to your door to know that you believe in summer all that I want. You know, summer we got it all. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. Again, the sky and our silhouettes dancing on the pavement, caught in a perfect storm. You and those eyes again, caught when I least expected. Said you're all that I want. We know, together we got it all. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. If I find myself at your door, would you follow me to better places? If I find myself at your door, grab the keys, let's go. I wanna taste this. If you showed up at my door, I would follow you to better places. If you showed up ready, let's go. Ready, let's go. Oh, oh, oh. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll dive in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite the echoes, secrets that we know, doors that open for us in a moment. Keeping the light on, righting our old wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over the rest, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all along. We can feel it, chasing the light is all we know. See in the forest, for the trees I'm keeping watch. All that is storming, waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over the rest, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all along. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the find strength to divide us. Gave it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we go. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we go. Sometimes we hold on to let go. Sometimes we hold on to let go. Sometimes we hold on to let go. There is nothing lost between us. And oh, I know you have your reasons. Some days I'm a mess, but I know there's a rainbow over all of the past. Your head on my shoulder, but I know we're better on our own. But this is how we go. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we go. Sometimes we hold on to let go. Sometimes to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know we've in the sunsets of paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two, because I'm missing you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now, 'cause I'm feeling worn out. It's getting to me, lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you. Feeling you can't ignore. Do you ever stop to feel it caught in the afterglow? I'll come back to your door to know that you believe in summer, all that I want. You know, summer, we got it all. Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll dive in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it in.
Super excited to welcome you to the multimodality track for the AI Engineer World's Fair. Things have been changing a lot in the world of AI and LLMs. going from just text to now a whole world of multimodal inputs. We have a really exciting set of speakers here today to help you learn a ton more about this. And so I'm excited to welcome Rob Chang to talk about Substrate. It is their launch week, so give them a round of applause.
Hey, yeah, it's really good to be here. This is a particularly exciting talk for us because we've been working with private clients for about a year now, but this is the first time we've really talked about it in public since our launch last week. I'm incredibly proud of the work we've done so far and excited to take a few minutes to tell you about it. So if you look at the products out there that have really successfully leveraged this generation of AI, I think one thing is true about nearly all of them is that they're using more than one inference run, often many different types of models in tandem to accomplish a specific kind of task really well. And I think people really quickly realize that the foundation model is not enough, and even very simple tasks like summarizing a document to much, much more complex tasks like solving coding problems end to end, I think the best products right now are all using systems of inference runs in a logical structure. So I think at Substrate, we believe that building with modular intelligence is always going to be more effective than building with a monolithic intelligence. These systems are inherently more legible, which means you can understand them structurally, which means that they're debuggable and they're extensible. And evals become a lot easier because the decision trees are explicit and you can sort of verify at every step what's going on and what's going wrong. So Substrate, I think, is a sort of new approach to this. I think our model is sort of fast in ways that other paradigms can't be. It's sort of flexible enough to build any AI product out there, and it works at scale by default. So what is it? I think at its core, Substrate is a coupling of two things. First, I think it's a really elegant developer SDK that lets you describe a computation graph over any number of nodes. And the abstractions here are really general, and so we have a bunch of intelligence nodes across all the modalities that you might care about, which is like generating images, transcribing speech, generating text, JSON, embeddings, executing code. But second, Substrate is also an inference engine specifically built to run these computation graphs as efficiently as possible. So these graph representations here it's a representation of many tasks and their relationships. And since we run a very coordinated compute cluster, we can statically and dynamically optimize things like batching, caching, sort of networking, concurrency, physical placement, which really makes a big difference. And if you look at most frameworks out there, they're typically involving dispatching a bunch of API calls separately. And if you look at what happens mechanically when you do that, every step means you've got to resolve DNS, you've got to go through proxies, you've got to go through authentication, like balance checks, and all of that sort of adds hundreds of milliseconds of latency on every single step. And if you contrast that with Substrate, we transfer data from node to node, process to process on the order of microseconds, which is some 10,000 times faster, meaning that it's actually feasible now to run online applications that involve dozens of nodes. We've also noticed that JSON decoding is one of the most useful patterns for multi-inference runs, and I think we've invested a lot into offering a best-in-class JSON mode, both in terms of reliability and speed. And if you look at all of this together, I think what it means is that Substrate is really a way to enable higher quality outcomes with AI, letting you work in a system that's more flexible, it's more legible, it's more verifiable than any of the current paradigms that sort of exist now. I think there's a lot more to say. There's all the time I really have today. It's only 5 minutes. But if you're curious, please come out and say hi on the expo floor. you can scan this QR code and get some credits, and go to the website, substrate.run, or give me an email at rob@substrate.run.
Awesome. Thank you so much, Rob. And now we're excited to welcome Vic Kapati, who is the CTO at M87 Labs, to talk about MoonDream.
Hi, can you all hear me? I can hear myself. Hi, my name is Vic. I work on a model, an open source vision model called MoonDream. A little bit about myself before I dive into MoonDream. I was at AWS for about 9 years before I started working on this model. Looking at where the stock price is going, I'm not sure if that was the right financial decision, but I'm very happy with the work I'm doing. So let's dive into it. I'll talk about MoonDream a little bit. It is a tiny vision language model. It's less than 2 billion parameters, so it can run anywhere, and it's open source, Apache 2.0, so you can use it to do anything. Here's some examples of things you can do with MoonDream. You can ask it questions about images. You can caption images. It can detect specific objects inside of images. So here I asked it to tell me where the peak is, and it gives me coordinates. I can count stuff. It can do all sorts of things. I had the audacity to title my talk, "How Can a Tiny Vision Model Slap So Hard?" So I have to back things up a little bit. And so here's me doing that. These are two vision benchmarks, vision question answering benchmarks. One's called VQA-V2, the other is called GQA. As you can see, MoonDream has been steadily improving over the releases I've made over the last 3 months. I've included a reference line over there for Lava 1.5, which is a popular 7 billion parameter vision model. So this shows you that MoonDream gives you performance that's comparable to models that are about 4 times bigger than it. I didn't really set out to build a vision model, so I kind of got roped into it. I was originally trying to build an application that required an AI agent, so I needed to be able to see what was going on the user screen and have it describe what's on the browser page for QA testing automation. Tried to do this at first with GPT-4v, but there were too many safety refusals back then. Like if there was any human being present in the image, it would just refuse to process it. It was also going to be really slow and expensive. And so I realized if this is a product I'm trying to build, I really need to have control over the model itself. So I figured, you know what, how hard can it be? Let me just go try and build this model myself. Now, the task I was trying to perform here was fairly constrained. I just needed to describe screens and answer questions about screens. So it doesn't need to be generally intelligent. I had a couple of 3090s at home, so I figured I'd train a small version of the model at home and then rent some beefier machines in the cloud to go train a bigger version. Once I got done training a small version, I was like, hey, this actually works pretty well. So I posted it on Twitter. I thought, you know what, I might get 20 likes off of this, and then I'll move on with my side project at the time. It blew up far beyond expectations. I was a little surprised, pleasantly surprised, but surprised nonetheless. And I immediately started seeing other automated testing companies reach out and be like, hey, can I use this to describe browser screens? Because this would work really well for us. As well as other companies. Shout out to our friends at Open Interpreter from Seattle. That basically told us that I figured, you know what, like this is getting a lot of traction. Let me pause on the whole automated testing app for a couple of weeks and focus on MoonDream and see where it goes. Yeah, so let me dive into a couple of the technical details around what makes the model succeed despite being small. The first thing we did that I think really helped was deciding what problems the model should solve and what it should not solve. So MoonDream wants to be a developer tool. We focus on being really accurate and not hallucinate. It doesn't really have a lot of knowledge about the world. So if you ask it to write a poem, it's probably not going to help you. It's really focused on answering questions, like helping you understand images. This is really important because it affects the type of data that you use and the sort of benchmarks that you want to focus on. There's a popular vision language model benchmark called MathVista, which measures how good models are at solving math problems. You take a picture of a differential equation and you see whether the model can solve it. That was an example of a non-goal for us because we just want the model to be good at looking at images. The most we do is probably generate a LaTeX representation of the problem. We don't really want to even attempt to try and solve calculus. It was not pre-trained from scratch. We use we fuse a vision encoder called SIGLIP from Google with a pre-trained text model called Phi 1.5 from Microsoft. The notable thing over here is Phi 1.5 is also trained on mostly synthetic data, which is very similar to our pipeline, so it works very well. For this sort of task, pre-training from scratch doesn't really make a difference as opposed to using pre-trained models, and it is cost prohibitive. So unless you want to get those brownie points for saying you trained it from scratch, it's probably not worth doing. We experimented with a bunch of different other models as they were released, and nothing really made too much of a difference. What does make a difference though is training data. The latest release of MoonDream is trained on around 35 million images. And the problem is, especially when you're on a budget, like high quality multimodal training data is really hard to come by. There's companies that, there's a lot of companies out there that will annotate data with humans, but it's really expensive. And I've heard a rumor recently that they won't even talk to you anymore unless you're willing to sign an upfront 7-figure commitment. There's a lot of data on the internet, images, alt text pairs. The problem with this is it's often not in the format you want it to be, and it's really noisy, and the noise is really problematic when you're training small models. And so synthetic data is a way to solve this, where you use that alt text information, process it. It's a bit of an open secret that a lot of people are training on outputs from GPT-4. You probably don't want to do that. Besides being questionable in terms of use, it's often not helpful. GPT-4 is a very powerful model. It has reasoning capabilities and knowledge that your small model is never going to be able to get. And so when you train it on GPT-4 outputs, what it learns instead is to hallucinate. It's going to generate plausible sounding outputs that include details that it cannot possibly memorize. And so you end up in trouble. So this is a little important. I'm going to go a little more technically detailed for a couple of minutes to dive into how to do synthetic data. So bear with me for a sec, we'll pop back up. Here's an example of how not to do it. Coco is a data set. It has around 200K images. Each image has 5 short descriptions and a bunch of object annotations with like, hey, there's a bicycle at these coordinates and whatnot. And let's say you want to take the short descriptions and these object annotations and generate more detailed captions that include the union of all the information present over here. If you just naively call GPT-4 with this information, it generates this. Not important to read all of it. But there's 2 important things to note. The first is that it hallucinates. It says in the second paragraph, there's a person near the right side of the harbor. I think there's like a person way back. There's like 5 pixels there. That may be a post. It may be a person. We don't really know. That's because the object annotations were bad. But besides that, like the model is also taking a lot of creative liberties over here, like saying there's 5 yachts standing out from the rest and whatnot. And so this is, you need to do a little more pre-processing of your data before you feed it to the model. Here's another example. There's a data set from Google called localized narratives. The task annotators are given here is verbally describe this image, and as you're describing the image, hover your mouse over the part of the image that you're describing. So it's nice in that it encourages people to create really detailed descriptions that capture spatial positioning in the image. So for example, here it says the girl in the front is playing the guitar and whatnot, and spatial reasoning is something that vision language models typically tend to struggle with. I ended up having to build a fairly sophisticated data processing pipeline to get really good results with this. Not really important to dive into the details over here, but the important thing to note is, A, it gets really expensive. Each image ends up being 20 LLM calls, and the LLM here is Mixtral 8x7b, so it gets pretty expensive. But it was necessary. The training data is the biggest needle mover in terms of model performance, and because of this, I'd say we spent like maybe 1 or 2 orders of magnitude more compute on generating training data than actually training the model itself. So yeah, this particular data set we've open sourced. It's available on Hugging Face. Here's an example of the type of questions it generates for this image. There's an interesting question towards the end. What theory does the kid have about the existence of pleasure in the image? I'll talk about that in a sec. But basically, you want to generate a few distractor questions so the model knows to not always agree with the question that the user is asking. So yeah, a couple of the challenges involved in working with synthetic data. There was an interesting incident I had early on where a user was like, hey, I asked a relatively simple question, why couldn't the model answer this? And when I looked at it, it turned out that they didn't capitalize the first letter in their question, and the model had never seen anything like that during training. So I was like, what do I do over here? And so it's really important for you to make sure that your training data has the same rough distribution as your real world query. So ended up adding like an extra step where we artificially inject like capitalization issues and typos and whatnot into the model before training it. There's also this risk of what we call model collapse, where your model has biases inherent to it. So for example, if you try to ask Mixtral to generate distractor questions, hey, just generate a question that's completely irrelevant to the image, it'll always generate something about dinosaurs and aliens. And so if you train your model on that, it'll instead learn to say, hey, if the question is about dinosaurs and aliens, always say no, which doesn't really help. And so you need to inject like some entropy into the process of generating synthetic data to avoid this. In the case of synthetic captioning, you can do something like, hey, describe this image, but also consider the alt text on the image, which may be noisy, may be irrelevant, but if it is relevant, use relevant facts from that. And that tends to help a lot. All right, so popping back up, there were a couple of important learnings I had over the last 3 months that I would like to share with all of you. The first was the community was really critical in this whole journey. Seeing that original engagement that we got from the MoonDream release helped me realize that, hey, maybe this is more valuable than that QA testing application that I was working on, because a lot of people have a need for this to build applications like that. Coming from an enterprise-ish company, it's been really valuable. It's been refreshing to be able to just talk to customers directly, like send someone a Twitter DM and be like, hey, just saw you looking for this, what do you think? But it's also helped us connect with a lot of partners, mentors, and get a lot of support from the community. Being open source was critical. I kind of didn't really have a choice over here because the competition was free, so what am I going to do? But when you're in the DevTool space, it is pretty important. Open source is important to a lot of developers. They would like to have the ability to run it in different environments. It's also pretty important for a lot of enterprise users. In a lot of cases, they don't really want to run the software themselves, but having the option is very important to them because most enterprises have had situations where a vendor goes out of business or decides to screw them in some other capacity. It's also been really critical for engagement for us. We've had a lot of people in the community help out, port it to different platforms, run the model in the web browser and whatnot. So it's been very valuable for us. This one is a little controversial. I'm not sure everyone agrees with this, but I feel pretty strongly that safety guardrails should be implemented at the application layer, not baked into the model itself. This was one of my learnings from my first attempt to build a QA testing application with GPT-4v. It made no sense for that application to reject pictures of any picture that contained a human being. I understand why they felt it was important. DevTools are kind of B2B, not B2C, so it's important to make it easy for developers to decide what guardrails they want and implement it in their model as opposed to just deciding it for all users. I'm not saying this is not important at all. Kind of makes sense if you're trying to build an assistant to bake that stuff right directly into the model, but when you're building for developers, makes less sense. yeah, I believe pretty strongly now that tiny models are going to run the world. In computer vision, more so perhaps than in text models, efficiency is really important. In a lot of cases, you're really worried about cost because you're processing video, and 30 frames a second at 7/10 of a cent per second adds up very quickly and doesn't give you a lot of room to work with. But there's also situations where you're really worried about privacy or latency, and therefore you want to run the model really close to where decisions need to be made. Which is not to say big models are not useful. I think they're very useful. I just think that we'll mostly be running them in our development environments, maybe for generating training data. But the artifact that you're going to want to deploy is most likely going to be a smaller model. Another thing that was a little surprising to me was looking at the different things people were doing with MoonDream. There were a lot of people building new applications that weren't possible to do before because the model can understand language as well as images. But there were also a lot of people doing traditional computer vision things with the model. It's like, is there a person in this scene? Or is there something suspicious going on? Tell me where the bus is in this picture from a road camera. All of which was possible to do before we had transformers, like just train a YOLO V3 model or whatnot. The thing that was, the lesson I took from this was prompting is a much better developer experience than having to train a custom model. And so for a lot of developers that would be interested in incorporating vision into their applications, before they'd be like, you know what, it's not worth me spending 2 weeks learning how to like collect data and annotate it and train my own custom model. Giving them the option to say, hey, for fairly cheap, you can just in English describe what you want extracted from this image, makes it something that they actually consider doing now. All right, I think I'm a little ahead of time, so I'm excited to maybe do a live demo if the demo gods smile upon me, but we'll see. In conclusion, where's MoonDream going? We're not AGI people. I'm really focused on making it really easy for developers to build amazing applications with vision. There's a bunch of model improvements that I'm working on right now. I'll talk about some. Right now we use 729 tokens to represent an image, so you can only really send one image to the model at a time. We're working on giving users the option to like give a more compressed representation to the model, which makes sense if you're not trying to read text or something from the image. If you're just trying to do classification and whatnot, that makes the model run a lot faster, which is important, especially if you're on CPU as opposed to GPUs, which can't do as much. CPUs can't do as much parallel compute, and so that sort of thing ends up being really important. We've also just raised a seed round from Felicis, Ascend, and also the GitHub fund, which I forgot to include in the slide. Sorry, GitHub. This means more GPUs, but more importantly, it means I can finally get some sleep because we're able to get a couple more people to join the team. If you're interested, please reach out. We have a contact email on the website, or just hit me up on Twitter. We also have an exciting release coming up later this summer that I'm super pumped for, so stay tuned. I think that's about it. So I have a couple of minutes left, I think, so I'm going to try doing something that may not be the wisest idea, but we'll see how it goes. All right, I'll turn the Wi-Fi off. This whole thing is running locally. So what this is going to do is like start taking my webcam in, and it's going to use MoonDream in an infinite loop to describe what it sees. And we can ask it different questions. So we'll see how that goes. And yeah, you can ask it different things. So let's say, is the person wearing glasses? You do have to tell the model to answer briefly if you want a yes or no. Otherwise, it gives you like a answer with a single word. Let's try that. Yes. Okay, I'll take them off, and I can't see it. What's did it get it? Let's do that. I'll go back to the old prompt. All right, well, that was it for me. Thank you all.
Thank you so much, Vic. We are super excited to welcome our next speaker, Ben Hilac, who is one of the founders of Dawn Analytics, and he's going to be talking about the era of unbounded products.
Hey all, I guess actually I have this on, I don't need that. I'm so excited to be here with you guys today, and I think what is probably the coolest AI conference in the world at such an exciting time in history, I think, especially for AI products. If you don't already know me from either demos on Twitter or sometimes probably ill-advised, spicy takes on Twitter, my name is Ben Hilac, and I'm the founder of Dawn. So at Dawn, we help some of the best companies in the world, everyone from GitHub to Can of Soup, build better, more predictable AI products. My entire life, I've been really obsessed with building and designing unbounded products. So unbounded products are products that transcend the mouse, the monitor in some way, right? So for me, that started with robotics. When I think the first one was when I was in 8th grade. Eventually rockets at SpaceX, so these are very unbounded products, right? And then most recently, I was on the design team for the Apple Vision Pro for 4 years. So we designed the first version of Vision OS. I think that AI makes products less bounded than they've ever been, right? You can type, you can talk, you can show images or show video, just like we just saw. You can also sort of plead, you can bargain, you can confide, right? These are very interesting sort of input modalities. And this unboundedness often makes products unpredictable, right? Confusing, hard to understand. Users assume your product can do things that it can't. They try to do those things, doesn't work. And they walk away thinking that it can't even do the things that it can. When you talk to people, and specifically people that are not in this room, how they use ChatGPT, how they learn how to use it, it's often word of mouth, right? So they hear one of their friends say that they used it for travel planning, and then they go use it for travel planning. A lot of us in this room, especially like people that are more technical, we often learn through trial and error, right? So we just keep trying. We keep trying because we know that these models are good, right? We know that it's impressive. But a lot of people are not. They don't do the trial and error thing, right? So they try it once, it doesn't work. They don't try again. And so this talk is about making good AI products. And to that end, I'm going to cover just 3 things. So those three things are the past, right? So how have products become more unbounded, and what has worked for unbounded products in the past? The present, which is AI products today. What are sort of good design patterns and bad design patterns? And then the third point is going to be the future, right? So again, just three things, just the past, the present, and the future. Easy. So we're going to start with the past. So most software that we use lives on a screen, right? And you use it just by typing, you use it primarily by swiping, clicking, and tapping, right? When you click something, whatever the developer expected to happen is what happens, depending on how good of a developer you are. It's easy for users to understand what your app can do. They look, they see the buttons, they get it. It's also very easy for you to understand what your users are doing. You just add an amplitude or mix panel call on a button press, you see what they did. So if you think about one of the biggest changes to this, previous to the last 2 years, was multi-touch, right? And this is just like, instead of one pointer, you have two. But just by adding that second pointer, you get relative distance, you get rotation, right? And just this one little change, like, largely made the smartphone possible, right? Like, largely made it easy to use a screen that is that small. And now it's just getting crazy, right? It's like we have unbounded products everywhere. Products are so unbounded. You have software, just freely roaming the streets of San Francisco, getting attacked by fiery mobs, right? So this is getting crazy. And so I want to talk a little bit about just one unbounded product that's I got to work on, which is the Vision Pro. And what I want to talk about is just 3 lessons that we learned while we were designing it. Lessons that I think aren't as intuitive looking from the outside in. So I think that unbounded products are often defined by this what-if question. Like, when we were starting, it's like users get themselves into the craziest situations. So something as simple as, oh, well, what if someone's in the living room, and then they move to the bedroom, and they lay down on their bed, right? What should happen to your apps? If you're designing Mac OS that's on a laptop, you don't have to worry about that. But that's something we had to think about. And there's hundreds of more questions like this, right? What if someone's on a plane? What if someone's next to their friend? What if someone has a disability of some sort, right? Like they cannot move. They can't move their neck. They're bedridden. So all of these what ifs, and I think this is, again, what defines unbounded products, right? All of us that are building AI products, we're constantly thinking, oh, like, what if someone puts in this? What if someone puts in that? And there's evals, et cetera, et cetera. And so without structure, you just have chaos, right? You have a blank slate. You have all these what ifs, infinite world of possibilities. And so it's really on us as product designers to add structure. And structure is what creates clarity. So again, I want to talk about 3 ways we added structure. The first was highlighting what matters and doing it really fast. So the first thing you see in Vision OS is a home screen. It has apps, it has people, and it has environments. So those are the things that we think matter when you're using Vision OS. So they're the first thing you see. Might not sound that novel, and it's not. In a lot of ways, it's the same thing that happens on your iPhone. But when you compare it to VR products that came before, it's very hard to understand how you're actually, what is this thing good for when you look at this menu. The second point is hierarchy. Hierarchy is what gives unbounded products a shape and a purpose, right? It's what helps users understand what it's good for, what they should use it for. So again, we have the home menu. That's kind of where everything starts and ends for Vision OS. We have windows. They have bounds. You can resize them and move them. And any individual window can go full screen, right? So that was our hierarchy. The last point, which is really important, and I think the easiest way to make unbounded products feel familiar is, intuitive, I got ahead of myself, is familiar. Familiarity. It was something we hit when we were building Dawn. Our first kind of prototype was this star cluster thing that you could explore. It was really fun. Nowadays, it looks a lot more like this, which are, tables, and we have graphs and examples. Again, it's just structure, clarity. And I think that it's no accident that, the TV app on Vision OS looks a lot like the TV app on tvOS, right? It's not an accident. It wasn't laziness. When people are sort of in uncharted territory, you want to give them as many signs of home as possible. Same thing for Control Center, right? When people see Vision OS, they already know how to use it. So again, these 3 points. Highlighting what matters, bringing that to the forefront. Establishing hierarchy. And then leveraging familiarity. All right. And so that was the past. Now we're going to talk about the present. And specifically, we're going to talk about AI products. We're going to talk about ways, both good and bad, that products have been incorporating structure into their AI features. It's really important to note the right structure is very unique to your app, right? That's the whole point, is that it gives your app a shape, helps your user understand what it's actually for. So let's take something like Dot, right? Dot is a companion. Dot is sort of a journal, at least for me. And so the structure they added was that if you pinch out, you can see each day separated, right? It feels a lot like a journal. And if you tap a person, or 2 people, in this case my co-founders, I can see this, again, structured information about them and a timeline every time I mention them to Dot. And so again, you're pulling that structure out of the chat. Perplexity does a really good job of using structure to make their experience feel more like a search engine and less like ChatGPT, less like a chat you're having a conversation with, right? And they do this by, really pulling your title, your query up top as like a title, highlighting the sources it came from, and then having the answer below that, right? And then having that take up the full page, kind of regardless. So it makes it feel, again, like more like one shot, less something you're having a back and forth with. Now I want to talk about sort of an anti-pattern I've seen, which is, this is in the Vercel chatbot demo. I think Vercel does some of the coolest design work in the entire world. I didn't like this one. So this is like having this idea of almost ephemeral UI, but inside the flow of chat, right? And I get the appeal, right? So actually, if we go back here, sorry, this was the video I meant to show. You have a slider, right? So instead of having to you inquire about, you want to buy Doge, and it shows you this UI, so you can adjust exactly how many instead of having to do it over text. It could be good. The problem is that when it's stuck inside this sort of unstructured thing, it starts floating away as I try to ask follow-ups, right? And then at some point, I even have 2 of them, right? So I go back up to the first one, I press purchase, and now I'm interacting with something that's completely different. So it reminds me a lot of sort of the house and up, right? It's just kind of up, up, away. So instead of trying to put structure, stuff it into this unstructured thing, I think the answer is you pull it out, right? You pull it off to the side. And what that means is that as the conversation continues, you can just sort of update that structure without disrupting where the user is. And that's exactly what Claude did with artifacts, right? And I think why it's so successful is that they pulled out the structure, which is the app you're working on and iterating on, from the actual conversation. And then so as you make changes, you can even go between the versions here without even having to scroll in the conversation, right? So it's beautiful. And it actually brings us to another thing that I think has been really effective for AI apps, which is this almost concept of version control. So this was actually one of the shipping original ChatGPT features, which is kind of crazy. But if you edit a message, you can go between the versions, right? And it actually maintains this entire tree. It's very complicated, but super powerful. With V0, Vercel did something again, amazing, where it feels extremely familiar, almost like you're working on Google Slides or something. But you can go back and iterate, keep iterating on UI without having to be afraid that you're losing something, right? So again, versions. Again, I think familiarity is really one of the most important things for unbounded products. I think Claude did an excellent job with this. Again, I'm hyping them up here, but ChatGPT introduced memory across all of your chats, right? Completely unbounded. So when I tell it something about some sort of medical problem as I'm working on a JavaScript, it's like it knows that, which is very weird to me. I think this idea of projects and that structure of a project is very familiar. So sharing context across a project makes more sense. Agents are something that are extremely unfamiliar to most people. And this idea of having all these different tasks and you're feeding data between steps, whatever. But what is familiar are spreadsheets, right? Spreadsheets are extremely familiar to, not to me actually, but to a lot of people. And I think the only real uses of agents I've seen in the real world, are spreadsheets. So this is Clay, right? And each column is essentially a step that an agent is taking, the user is defining. So it's going across, building up kind of context across the spreadsheet. Each row, it's often almost, you do it like an eval, right? So it's like you run the first 10 rows, and then you run the next 50,000, 100,000, right? So you get it right. And you can see here, eventually you end up with a personalized email as the last column, but with all these steps in between. The next thing that I think is extremely effective in helping people understand what your app is for and skipping all of the sort of noise of prompt hacking, prompt engineering, are examples and presets. So ChatGPT, I think, was the first for this, where they had these, message to comfort a friend, plan a relaxing day, and so on. V0 does an awesome job with this, right? We're not just having those suggestions below, but they also have an explore page where you can see what other users are doing, what's actually working, right? Again, try to shortcut this prompt, blank canvas problem. Notion as well, right? They have a simple menu where you can change tone for text instead of having to be like, you are a very concise GPT, whatever, right? So you're just using these tried and proven things that Notion can validate. And that last point brings us to the future, right? So where are interfaces going in the future? Linus gave an awesome talk last year where he described prompt engineering as this almost trying to drive a car, a llama trying to drive a car with a pool noodle from the backseat was, I think, his metaphor. And there's some real truth to this, right? And so I think, first of all, the future has a lot less prompt engineering. And we're already seeing this, right? We're already seeing this with generative images, the way that Apple designed it, where you're mixing and matching these different concepts. You're able, there's a ton of demos on Twitter of people, essentially you're going between emotions here in a more intuitive way. And then just yesterday, Figma released this way of adjusting the tone of text, right? Where you're going between professional, casual, expanded, concise. The problem with this is that casual means a lot of different things, right? Casual for a Fortune 500 company and a direct-to-consumer cosmetics brand with ads on TikTok, right? These are very different things. Casual when talking to your best friend or a coworker, these are different. So how do we avoid being reductive when trying to offer these sorts of presets? And the answer is you just I don't know exactly how many zeros I put here, but you just million X or billion X the number of presets, right? So you have enough presets for everything. And I think sparse autoencoders show a really promising path towards that. So if you guys have tried Golden Gate Claude, where you can kind of identify the one feature of Golden Gate bridgeness and amplify it, and it makes Claude obsessed with Golden Gate bridges specifically, or the Golden Gate bridge. My friend Giddis has an amazing demo towards this, but for manipulating images, right? So you can see here, he's increasing the amount of play of light and shadows, increasing the amount of serene forest streams or Venetian canals, in, again, a very controllable and predictable way. Okay, but so now we have a million, billion options, whatever. how do we avoid too many options? I think this gets to point 3, which is ranked presets. So these are presets that are personalized, searchable, and even invoked through natural language. They might not even be directly visible to the user. So the user types in something like more friendly, and you pull up the corresponding presets, like kindness, how close you are, how confrontational it is. Again, maybe they're directly editing it, maybe they're not. And this gets to the last point, or second last point, which is developer-defined personalization. So as soon as you're able to define those sort of features, you can start tuning them per user. So each user, in a way that you can't do with just text prompts today, right? Because text prompts are sort of this fragile house of cards, where if you remove one word, the whole output changes. So you're able to tune it per user. And the last point, and especially true, as you start, your app is going to become increasingly different per user, is shifting from evals to analytics. I don't think there's going to be some objectively correct, for a lot of domains, answer to things. Like, who was the first president? Yes, but the right sort of tone for a summary for a specific user, I don't think so. And so I think that increasingly, it's going to be about how do you understand if you're meeting the needs of your users and what they're asking for. So that's it. Thank you so much. Oh yeah, we'll skip this one. And thank you so much for coming. And yeah.
Awesome. Thank you so much, Ben. And now we're excited to welcome Karan Goyle from Cartesia to talk about state space models.
Can everybody hear me? Awesome. We'll see if I can stay on track, 18 minutes. So great to be here. I'm Karan. I'm the CEO of a small company called Cartesia, which is a 8-month-old company. And I'll tell you a little bit about what we're working on and try to describe some of the challenges that we see in sort of multimodal intelligence emerging and how we plan to fix them. And hopefully actually show a demo as well, if Wi-Fi works. So maybe to set the stage a little bit, the last 4 or 5 years of AI have basically been really focused on this idea of batch intelligence, which is sort of pretty core to this idea of building like an AI system that can reason for long periods of time on a problem and then solve it. So you can think about like math problems or physics problems that are hard. There's a lot of applications where actually what you need are systems that are streaming. So they're real time, they work instantly. So imagine generating video, audio, or doing like understanding applications on sensor streams, et cetera. So it sort of bifurcates where there's these 2 different types of applications, similar to how there's generally this idea of having batch workloads and streaming workloads. And so a lot of what we've seen over the last few years has really been focused on batch APIs, where you call a model in the cloud, it takes a few seconds, and then you get a pretty good response back. And now we're seeing some shift towards more real-time applications, where you constantly will be querying a model and asking it to return responses at low latency, and then using that to sort of interpret or generate information. And I think this area is really exciting because it's going to be transformative to a lot of interesting applications that have so far actually not necessarily been the main focus for a lot of what we've seen over the last few years. So conversational voice is an example of this, where you should be able to interact with a system and then talk to it. And it should be able to understand you and do all kinds of tasks on your behalf. This is similar to having assistants that are on device and run kind of really efficiently at low power at all times. regardless of whether you're on a phone or laptop. And then things like world generation, where like you can imagine actually playing a game that is generated in real time, similar to how the graphics are rendered on GPUs. All of this should be able to happen in real time, on low power, on your phone, on your MacBook, et cetera. Robotics is another great example where it sort of culminates with all of these coming together on a single device that is trying to kind of interpret everything in the world. And so I think this is sort of the exciting intersection, which is like, how do we make intelligence faster and cheaper so that we can put it everywhere, basically. And a couple examples that are really powerful. Real-time intelligence for conversational interfaces is going to be really interesting because you would be able to have an agent that can provide customer support for a problem, answer questions about health insurance, call your vendor to pick up a shipment. All these coordination tasks that generally are annoying to do should be really automated, and real-time intelligent agents should be doing them. And then humans can spend their time solving sort of harder problems that are more interesting. And in customer support, that could be dealing with the tail customers that are much more important because they're pissed off, or they're more important because they have more customer value, et cetera. And similarly in robotics, there's this idea of like ingesting, similar to humans, like audio, video, sensor data, and then responding instantly to a lot of these pieces of information. So I think this is sort of the world we should be living in, where all of these intelligent models run super fast. They solve all these different problems, and they're able to really kind of power these new experiences that are interactive at their core. So this is where we come in. We're building these real-time foundation models. So some of what I'll talk about is the work we've done in really building kind of new ideas for how you can create deep learning models. So I did my PhD before this. I was working with a lot of these folks for my PhD. Chris was our PhD advisor. We were really focused on this idea that you should be able to have a model that can compress information as it comes into the model, and use that to really kind of build powerful systems that are streaming at their core. And I'll talk a little bit about this, but that's really the technology that we've been working with for the last 4 or 5 years. We've been developing in academia, and some of you might have heard of things like Mamba, which is sort of a more recent iteration of this technology. I did my PhD working on some of the early iterations that nobody uses anymore, but are sort of the precursors to a lot of the modern stuff that is now more widely used. And now what we're doing at Cartesia is basically taking this and trying to understand how we can improve it. How do we push the boundaries on what architectures can do? And I think it's an interesting question because we should not settle for having one way of doing things. I think that's sort of a poor way to kind of think about the future. So our approach is sort of like, let's think about new ways of actually designing models that aren't necessarily built on, let's say, the transformer architecture and the standard recipe for deep learning that's prevalent today. And I think it boils down to this question of like, efficiently modeling long context is a huge problem because a lot of practical data is really long sequence data. I think text is maybe the least interesting long sequence data because text is actually fairly compressed already, right? Like you have a lot of information that is embedded in 2 minutes of, or 2 sentences of text. But there's all these other domains where, audio, video, et cetera, where there's so much information. Imagine looking at a security camera for a day. Like you would probably have just so much information coming into the system, and just very little of that would be useful. So compression is kind of really fundamental to intelligence because we're able to do this, where we can look at all this information and then sort of compress it down to whatever's necessary to remember or understand. And I think so far what we've seen is that the AI systems that we built have not necessarily exhibited that same behavior. So they're really kind of built not on the principles of compression, but more on this idea of retrieval, like keeping all the context around and then using it to reason over all the information that you've seen. So I think our kind of point of view is that multimodal AI will remain challenging as long as you're sort of working in this paradigm, because if you try to think about what humans do in a year, you're basically processing, understanding about 1 billion text tokens, 10 billion audio tokens. These are back of the envelope calculations that I did. And about 1 trillion video tokens, probably underestimates how much video we process. And not including all the other sensory information that you're processing. And you're doing it simultaneously. And you're doing it on a computer that fits in your brain. and you sometimes don't eat and drink, and you're still functioning fine. So you can have variable amounts of power in the system. So I think the idea that like intelligence is solved is sort of very far from the truth, because humans just are an extremely amazing machine that does something very extraordinary in a very compressed way that our AI models can't do. So I think that's sort of our, the reason we get up in the morning is we think about this and we're like, yeah, we're very far away from where we should be. And the best models today are in the 10 million, 100 million sort of token range. So that's really good. A lot of progress has been made, but really this is sort of what we aspire to, is how do you kind of build these machines that are long-lived, that can actually understand information over very long periods of time. And I think the cool thing is, like, as a human, you can remember things that happened 30 years ago with very little effort. You don't need to do RAG or retrieval or anything. You just, you remember it. It's gisted in your brain, and then you figure it out, basically. So I think that's kind of an extraordinary capability that we should be able to put into our AI models as well. And so some of the big problems with models today are, they're built on transformers, really optimized for data center. I think we see this with like a lot of the work we did, which was on subquadratic models. So quadratic scaling and context length really just means that the amount of computation you have to do to process long amounts of context is very large. And so right now, the sort of predominant approach is to throw compute at that problem and then hope that that would scale. Obviously, compute is a very important piece of the puzzle, because you do need more computation to be able to do more difficult things. But this type of approach, because of the quadratic scaling, actually has poor scaling with very large multimodal contexts. And text contexts tend to be shorter. Multimodal contexts will get larger because you have just way more tokens and information that's going into the system. So that's going to be a big challenge for these models, especially how do you do this inference efficiently so you're not burning down the data centers to do a fairly limited amount of inference. Like, you have to imagine that we're doing 1,000 times or 100,000 times more inference, and then if the models are scaling the same way, it's going to be really, really, really expensive. So you're not going to be able to permeate all these applications that I talked about very easily. And so that's sort of a big challenge, I would say. And so again, our hypothesis is you need new architectures, and that's kind of where we spend our time. And we want to make these models more efficient, faster, more capable, while being able to handle all these long context problems. This is a slide about transformers being somewhat inefficient at handling this, but obviously a very good recipe for scaling these models out. And so some of the work that we've been doing is new fundamentally efficient architectures. So they have compression at their core. So they sort of, the way they operate, I have a slide on this just to give you kind of a quick illustration, but they really scale more linearly in context length. So you should be able to have, because of this, like more low power implementations of these models, you can compress information as it comes into the system. You have low memory usage, and you can actually scale to much more massive context because of that. And this is all the work around SSMs. I just threw this nice slide, which I thought was cool. Jensen had an interesting quote about SSMs in one of his Wired articles that I like to keep talking about. But I think it's a cool technology that has a lot of potential, and sort of that's where we're spending a lot of our time. And if you folks are interested in reading more, there's lots of videos on YouTube and lots of sort of resources that try to make this more accessible to understand and kind of get into some of the details. But the working intuition is basically transformers are generating quadratically by attending to every passed token of information. So as tokens come into the system, you're sort of keeping them around and then looking at all the passed tokens. If you want to generate the word jumped from the quick brown fox, you would actually look at the entire context, try to understand what the next word should be, and then generate it, push it into the context, do it again. With SSMs, you just have a streaming system. So you have a token stream in. They update an internal memory for the model, and then the token gets thrown away. So that actually really simplifies the system, and that's why it's such a core sort of streaming interface, because you're just not keeping all this memory around about what happened in the past. You're compressing it into some sort of zipped file state inside the model that's going to be used to do future generation. And so this is sort of taking this idea of, taking advantage of this idea of recurrence, which is sort of core to how even humans do a lot of their reasoning. And last few months, a lot of these models have been getting adopted. So it's great that a lot of folks are now excited about the this alternate way of doing things that is much more sort of oriented around this idea of recurrence rather than retrieval. And so I think like we'll see a lot more activity in this, especially with multimodal data becoming more important. And you know, a lot of the challenges of multimodal data around efficiency will mean that I think that these models will have more of a role to play in the next 3 to 5 years as we also do our work in scaling them up and making them more interesting. A lot of people ask me about quality. I only have a few minutes, so I'll go through this, the rest of the slides super fast. But you know, SSMs generally have the right quality. Obviously, there's a trade-off between compression and keeping all of the information around. But actually, like, compression can be helpful. So if you imagine the security camera example, if you're watching 24 hours of footage, actually compressing all of that information on the fly would help you solve tasks and answer questions better, rather than looking at all 24 hours every time. So I think that's sort of the rule of thumb to think about, which is compression super helpful for a large context, not as helpful for short contexts. And so we see that quality actually is very good for long context problems and multimodal problems. Let me talk quickly about some of the work we've been doing. So we've been starting to work on sort of multimodal data, and we did a release a few weeks ago for a voice generation model. So this is sort of text-to-speech, and sort of in line with some of the work we're doing to bring more multimodal data into a single model, and use SSMs to power the inference and the training and so on. So this is a model you can actually play with. I'll try to show you a demo, but one of the things we're proudest of with this model is that we really shrunk the latency down. So when you play with it on the playground, you get instant voice back generated from the data center. And there's some cool work we're doing to actually run these models on Mac and other devices so that you can basically have the same experience as you have in the data center, but on any device, and do that efficiently and at low power. How much time do I have? OK, we're out of time, but I was also almost done. So go to the website, play.cartesia.ai. I unfortunately couldn't walk through the demo, but play with it and send us feedback. This is my email in case you want to send me a note. Would love to hear feedback and anything that you folks find interesting. Thank you.
Breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll dive in and I'm ready to holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding a match, strike it and ignite my soul. I'll dive in and I'm ready to holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll dive in and I'm ready to holding my breath and I'm ready to go. I catch you laughing and I'm Sunlit up the boulevard, driving slow, racing in your car, singing along every night. Must have played that song 100 times. Made on fire, we were lighter than the summer breeze, dancing the records in your bedroom like the 70s. Always on my mind, you ain't the music on my mind. everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burn up your will on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. See in the forest, for the trees I'm keeping watch. All that is storming, waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we grow. This is how we grow. Sometimes we hold on to let go. missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know even the sunset's in paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you. You wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. You wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. starving for something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna? Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. We are a summer storm, a feeling you can't ignore. Do you ever stop that we know, doors that open for us in a moment. Keeping the light on, righting our old wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is cut up over the rest is coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. See in the forest, for the trees I'm keeping watch. All that is storming, waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is cut up over the rest is coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all our hopes. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I Taking one more breath beside you, so I could find strength to divide us. Give it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we grow. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know even the sunset's in paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, now, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you.
Hello, hello, and welcome back to the afternoon session of the multimodal track. We are super excited to get started with Chang and Noah Schwach talking about the hierarchy of needs for training dataset development.
Oh, wait. Okay, I think this thing is on. Hey, everyone. Thanks for coming to our talk. Hopefully everyone didn't eat too much and you're not too sleepy from the lunch. But we're excited to be here. And we're excited to be talking to you about training dataset development for LLMs. So my name is Chang. I'm the CEO and co-founder of LanceDB. I've been creating data tools for data science and machine learning for almost 2 decades, starting with being one of the co-authors of the Pandas library a long time ago. Spent a bunch of years in big data systems and recommender systems. And most recently, I started this company, LanceDB, which is the database for multimodal AI. And these days, I spend about roughly equal time tweeting and on GitHub.
And yeah, hi everyone, I'm Noah. I currently lead the AI data platform at Character. And Character AI is one of the leading personalized AI platforms. So we train our own foundation models as well as run a direct-to-consumer online platform. And I focus on data research. So since we train our own foundation models, we need to learn what we need to train on to engage our users. And so we're focused both on academic benchmarks as well as things like A/B tests and trying to get more engagement on our platform. My team is focused on research acceleration as well. So we tend to build a lot of tools and leading to this collaboration with Lance and how we think about storing our data. So I think if there's one thing I want to convey with this whole talk is that you should really care about what you're training on, and you should care for it by giving it a nice format that does a lot of nice things for it. I wanted to start just kind of broad strokes talking about how we think about pre-training and how we think of post-training. There's definitely a lot of overlap, but at least in terms of pre-training, you tend to think wider, right? You want to think about more like what domains you're training on. Are you thinking about books or more chat data? And then you want to also think about quantity, right? How big is your model? How many tokens do you need? Compared to post-training where you're looking at very specific tasks, it may be not just looking at the context of that task, but also how difficult is that math problem? How easy is that multiple choice problem? So you kind of have to get much deeper and more granular in terms of the things that you understand about your data at scale. In the middle, I guess I've grouped together some of my favorite problems right now that a lot of people are looking into. So ranging from data efficient learning, right? How do we reduce the amount of data we need to get good results from a similarly sized model? How do we sample from data, right? Like what kind of metrics do we need? And then how do we look at diversity, right? Measuring diversity is very difficult, and looking at some of the automated ways that we do that in industry and all the different papers that are out there. So everyone loves a good hierarchy of needs. I think that for us, we always start with clean data and quickly go right up to evaluations. For us, we always start there because it's hard to measure anything without a compass. And since we're focused a lot on post-training nowadays, having systems for dataset management is becoming more and more of a problem. So when we are thinking about mixtures, right, these collections of data sets, and usually you have different weights of how you're including them in your batches and in your training sets, you want to understand those collections not just in terms of what data set they are, is this Wikipedia or is this some other thing, but also what's in there, right? So it naturally rolls up into analytics. So we want token counts, an understanding of length, and you might even want things that are more complicated, right? So you might be classifying your code data into not just, say, is this Python or is this Java, but also how difficult is it? How many functions are in this problem? How many classes were you supposed to generate? And really having more and more analytics lets you understand your data more. I think more than anything, reading data has probably been the biggest win. So these are kind of just ways of automating things that we've learned from looking at data, looking at outputs, looking at performance, and trying to understand what is going on. Everything in kind of the top half, I guess, of this is more about using language models to improve language models. So things like synthetic data, things like quality scoring, things like dataset selection. And dataset selection is probably the simplest and one of my favorites, right? You're just kind of looking at ways to match distributions for the behavior you want from your model and the data that you do have. And so a lot of what we do is do retrieval or do clustering. You can embed the web nowadays pretty quickly, And how do we pick the data that we like according to what kind of evaluations we're looking at? Quality scoring is similarly simple. Like, we build a lot of classifiers in-house for a variety of things. And there's a lot of cool work around how people are actually doing this with just prompting classifications. So you can do it even more simply than, say, having to go down the route of actually building a classifier and evaluating it and doing that whole loop. And synthetics, given the way that we've structured our platform, is also super powerful for us because we have this ecosystem of big data tools like Spark and Trino alongside some GPU-backed services for doing prompting, for doing embedding, and for classifying things. And so we can enrich our data sets, we can augment them, you can generate quick examples of, say, preference pairs, and try to explore a method not at its peak of quality, right? Synthetics are going to have problems, but you can start getting signal for what types of data, what shape is that data, and how can you kind of start looping in human labeling to make it even better. So at the top, right, we use human labeling a lot for improving these classifiers. And we also want to use them for rewriting synthetic data that maybe has issues, or rewriting data that just has issues in itself. And so all of this kind of comes together to motivate a lot of our platform tooling. And we'll go on to the next slide to talk about kind of how we try to make all of this easy for researchers working in this domain. So I said at the beginning, accelerating research is a big part of this. I've included some beautiful YAML here that hopefully people can see that there's a SQL block over there. And I think that this is pretty motivating in terms of how we materialize data sets. So if you've worked in machine learning at all, you know that usually you have a specific training format. Maybe it's TF records, maybe it's JSON lines, depending on where you're coming from. And at least in my experience, it's one of the most error-prone components of training, right? I don't know what data this is, I'm training on it, I'm getting weird results. So for our team, since we're doing so much iteration around data, making it part of your training job and separating concerns in terms of how your data is materialized and what your training job is doing is really, really nice for us. And this is kind of where land started becoming a big deal, especially as we start thinking about multimodal and how the data volumes are much, much larger, and the problems that we're trying to solve become much more complicated. So the materialization service aside, you know, it's kind of this nice interface that you send it some request and it gives you some list of files. Really starts hitting the road when we think about data loading, which is its own problem in and of itself, especially once data volume becomes really large. So Lance has this nice property that Chang will talk about a lot more that allows for quick random access, and it lets us shuffle data very cheaply. Right, so it essentially lets you shuffle references to rows rather than shuffling the rows themselves, which allows you to save a lot of time and iteration speed. And at the end of the day for us, we just want to watch the GPUs go burr and the numbers go up. So I'll pass over to Chang, who can talk a lot more about the Lance format in detail.
Thanks. Cool. So you've heard from Noah about the importance of data in developing models. And so if data is critical, then it's also critical to have the right data infrastructure for your workloads. Now, AI workloads tend to be a little bit different from your traditional data warehousing, OLAP, and analytics workloads in a couple of different ways. But let me give you just one motivating example. If you think about a distributed training workload, typically it breaks down into 3 steps. You have a filter. You want to select the right samples from your raw data set. Then you'll have a shuffle step where you will then draw random rows from the filtered set. And then you'll stream, typically if the data set is large, you'll be streaming those observations, whether they're text or images or videos, from object storage into your GPUs. So in that one workload, you needed fast scans to run the filter. You need fast random access to do the shuffling, and then you need to be able to deal with potentially very large binary data, large blobs, to be able to quickly stream data directly into your GPUs. So these 3 properties are required often in one AI workloads, from training to search and retrieval, but existing data formats and data infrastructure is good for at most 2, but often just 1 of the 3. And so this is what I'm calling the new CAP theorem for AI data. And that's the motivation for us for designing Lance format, around which we built LancDB. So this problem is, of course, exacerbated by scale of AI data, and especially multimodal data. So if you look at tabular data from the past, one row of tabular data with just simple scalar columns, on average, it's about 150 bytes per row. If you add embeddings to that, that gets about 25 times larger, depending on the number of dimensions. If you add images, that's another 20 times. And if you add videos, that gets pretty astronomical. And that's one single row. And with generative AI, data isn't limited by the speed at which manual human interaction can generate observations. New rows of data is being generated at thousands of tokens per second. So scale often blows up. In the past, as I've been in data for a long time, if you were in the tens of terabytes, you were a fairly large company. And I think these days, if you're working in generative AI, it's not unheard of for 10-person, 20-person teams to be managing like tens of terabytes to even petabytes of data. So what does LANS format do to solve these problems? Well, so LANS format, first, it's a columnar file format, so like Parquet, or optimized for AI. So it gives you the ability to do fast scans like Parquet. It supports fast lookups, unlike Parquet. And we've actually gotten rid of a big limiting factor in Parquet called row groups, and so that we can allow you to store blobs in line. LANS format is also a lightweight table format, so as you add data, it's automatically versioned. You can also add additional columns without having to copy the original data set. So it makes it a lot easier if you're working with large multimodal data sets to add experimental features and then roll them back later on. And we'll call this a zero copy schema evolution. And then finally, of course, it supports time travel so that oftentimes if you make a mistake or there's an error or there's bad data, it's instantaneous to roll back to a previously known good version so that it doesn't corrupt downstream model training processes. And the third aspect of LANS format that's really interesting is indexing extensions. So in Parquet, there are indices, but the indices can quickly tell you which rows you need. But with Parquet, because it doesn't support random access, even if you know which rows you need to fetch, it's really slow to fetch those rows. And not so with LANS. So with LANS, we've added indexing extensions for embeddings. So you can do essentially billion scale vector search directly off of S3. We can have scalar indices to make filtering metadata columns really quickly. And then full text search indices to do keyword or fuzzy search and directly from your S3 data set, and you don't really need that Elasticsearch cluster anymore. So what LANS gives you is the ability to have a single table for many, many different workloads. So if you have metadata columns or time series columns, you can run SQL. So you can plug LANS directly into, say, DuckDB or Trino or Spark, and you can run SQL on that. And if you're storing large blobs and tensors, like the videos or text or images, you can plug your LANS data, the same table, into PyTorch training. And if you have embedding vectors, you can use the embedded vector index to do similarity search. And so this makes it a lot easier for a full AI workflow, from analyzing and exploring your data set to searching and retrieving throughout your data set to fine-tuning and training your model. Around this format, we've built LANSDB, the vector database, and more generally, database for multimodal AI. So one big feature is a distributed vector search. So search through billions of vectors at low latency and very high QPS with order of magnitude less infra than other vector databases. And it provides data infrastructure for all of your multimodal data needs. When we talk about multimodal, we often think narrowly about just image generation or video generation. But when you look at the data, multimodal, I think, has many different meanings. One, of course, is the data. The data can be multimodal. So unlike traditional tabular data, we can store features, and then audio waveforms, images, and all of that. That's what we're familiar with that already. And of course, vectors. And vector is a vector, so whether they're image embeddings or text embeddings. Now, the workload can also be multimodal. So not just running OLAP SQL, but you can run vector search, you can run full text search, filtering, and then and other sort of data frame and SQL workloads. And then finally, the use case in the scenario can also be multimodal. So operational scenarios where you're in a production service for RAG or search and retrieval and personalization, or LANs can be used in training, or it can be part of your data lake to analyze and explore all that multimodal data that you have.
Yeah, so I think that from at least my team's experience and a lot of what Chang is describing, we just think that speed is probably our best bet in terms of strategy. And a lot of the tools that we've worked with really slow down under load, under new multimodal needs, and we're looking to develop out what the future for those data systems looks like. So thanks so much for listening to our talk. Yeah.
Codes, both Character and LandCV are hiring. On the I guess your left is the job board. The QR code for Character's job board, and our LandCV Discord is on the right. And yeah, check us out. Thank you for coming.
Thank you.
Up next, we are really excited to welcome Stefania Druga, who's going to be talking about the multimodal future of education. She's been doing research in this domain since 2015, and so we're super excited to hear from her.
Thank you so much. Is this on? Yeah, can you hear me? Hi, hello. I think it's on. No, it's not on? Very faint. Very faint. Yeah, perfect. Hi, everyone. I'm Steph. I'm going to talk about the future of education with multimodal AI. We are here at AI Engineering Summit, and AI engineering starts very early. So I'm curious, how many of you have kids? How many people in the room have kids? OK, wonderful. How many of your kids have played with generative AI so far? OK, so you won't be surprised to see the next slide. Basically, 70% of generative AI users are from Generation Z. This is a recent study from Salesforce. So it starts very early, and the reason I care about the future of education with generative AI is because education needs a wake-up call. So we know that early literacy rates, she can run around the room, and the robot is constantly going to try to find her. Now, this is the first step. It's using, like I mentioned, a block-based programming language, expanding Scratch, and at the time, like, it allowed kids to not only program their smart lights, their voice assistants, but also train their own custom models. So they can train models with examples of images or examples of text, and then use those custom models in their own games and application. So for example, here, like, this student trained a model to distinguish between unicorns and narwhals. And then not only it gets a prediction when it plays with a game, but it also gets the confidence level. How confident is his custom model that the drawing is a unicorn? And we see the confidence is pretty low. So they made all sorts of things, like looking at what's in their food, trying to program games like rock, paper, scissors, get the robot to talk like Shakespeare. And this was used all over the world. It's translated in more than 30 languages. And the good news is that we evaluated this to see how it increases that critical understanding of AI and how it helps with AI literacy. So to do that, I did a longitudinal study in public and private schools where we asked questions of what kids think about AI before. Then we allowed them to engage in AI learning activities, and then we asked the same questions at the end. And what we found after they learned how to do text training, image training, smart home programming, is that they became much more skeptical of the AI smarts. Like in the beginning, they would say like, yes, Google Home is smarter than me, or this model is much better than me. And after they learn how it works and how to train it, they were not so sure it's smarter than they are. And I'll show you a quick video to see how that went.
Everyone has heard about machine-based learning or artificial intelligence, and there's really sort of no question to ask for a lot of the more tech-savvy parents. It's like, go for it.
Technology is going to be a huge part of their lives, much more so than my life. If it's scary for some people, this AI technology, I totally get it. But as a parent and as a teacher, I thought it was really important because these are skills that 21st century kids need to have.
When my dad was young, he bought a car and took it apart to see how it worked. So you teach people that young how these things that grown-ups mostly program, how it works.
So as I was saying, AI engineers in the making, and this is the significance difference to their perception of the smarts of AI before and after doing these learning activities. So why did that happen, right? Why did they become more skeptical, more critical, and also more literate in how to read and write with AI is because by providing this platform and allowing them to tinker and form hypotheses and test them, we basically allow them to engage in the scientific process, just like researchers do, just like we do, right? But we needed to have the right sandbox, the right platform for them to be able to quickly tinker and quickly iterate. So kids are not alone in learning this. Parents need to learn too, teachers need to learn too. And we've seen during the pandemic when kids were stuck at home with parents, a huge opportunity for them to learn together. So I'll show you one of the early demos of Cognimates. Oh, the audio is not working on this one. I'm not sure why.
There you go. You did it. No, I need you to help me ask a question. For that, we'll need the Ask block. See if you can find it. Awesome.
So the thing that you're programming is kind of collaborating with you to teach you how to program it, right? Just imagine applying that to any of the chatbots we have today, right? Like when you're not happy with the answer, or maybe the answer is not age appropriate, or you want to teach, you also want to teach something to the model about your language, your culture, weird facts that you're interested about. How do we do that, right? So I did another study where this was with kids and parents in 10 different states in US over multiple weeks, where we wanted first to learn how do we design a co-pilot for programming for families. So before we start and build it, like what do they want? What works and what doesn't? So what we found was that some of the things that kids and parents liked the most was to generate coding ideas with an AI friend, like if they had a co-pilot in Scratch. And this was very, very helpful. Here are some quotes, because like here, like one of the participants says, most people would like coding with AI friends because one of the hardest parts of your project is when you start, you run into a wall because you're out of ideas. So the AI friend helped with that. It also allowed them to express and elaborate their ideas in code. So if they had an idea for a game, like I want to make the bear kind of jump over the hedgehog, but they didn't know how to do it, it would kind of help them find the right code constructs to do it. And more importantly, it supported their creative coding identity. So it wasn't the bot that was making all the coding. They were doing it. The bot was just helping them when they were stuck. So this was very, very important. It encouraged kids and parents to work together, which is not always easy, right? Like one of the things I discovered, I've been working with kids and families for a long time now, since 2015. It's not always easy. So actually having like a third moderator to be like, oh, what does mommy say? What does daddy think? Take turns, try this, really help with family joint engagement. Also, it doesn't always work, right? Sometimes it's too distracting, and it was very important to enable families to shut it off. Maybe they want to do the game alone. They want to do the coding alone, so they could stop it whenever they want it. If you have multiple siblings that fight over the laptop, it cannot help with that. Or if the concepts were too complex, it was not able to scaffold it always, like break it down, so parents were very helpful to help. So after understanding like what are the core things that families want from co-creating and learning how to program with an AI friend, I went and basically evaluated all the generative AI models to see if they could do that, right? So for Scratch, like top generative AI models are pretty good at generating explanations, giving like ideas or questions to help kids and parents like explore like and test like new games. And this was published. We created a benchmark as well for measuring this. And this is just an example of what the future of education with multimodal AI could look like. If it's applied to Minecraft, to games, to physics simulations, science simulations, it can become a creative sidekick, right? There are a lot of people who love to build things with their hands. What if I could get ideas like by taking pictures of flowers I like and colors I like, and it gives me ideas and helps me like generate 3D models and that I could afterwards print and paint. Or I'm into knitting and I want to use a generative AI model to inspire my knitting projects. It can also be a learning companion and a coach. It can help with math. So together with Nancy Otero, we created the first benchmark for math misconceptions to show what are the most common math problems that kids have in K through 12 and evaluate how good are top-of-art generative AI models in identifying these misconceptions when kids talk with a chatbot. And I put a link to it if you want to download it. So I am here to invite you to think about AI engineering and AI tinkering for all ages, and how do we go from my experiments to Cognimates to things that people are doing and tinkering with Hugging Face and make sure like we open up the space. So we use AI not just to teach, but we actually use AI for people to learn how to tinker and learn by playing and learn by doing. So I like to do what I preach, and I'm going to show what I tinkered with AI last night. These are very fresh demos. So this is using the latest Gemini API. And I have 3 demos. Let's hope they work. Let's start with the science one. And I was hoping to draw in real time, but I don't have a table. So luckily, I have some drawings, and we'll see how well this works. So I have a drawing. Oops. A scale with a weight on each side. What would happen if you add another 5 kilograms? So it's asking me questions based on my drawings, and then I can make a new drawing that has like 10 kilograms and 10 kilograms and see if that gets better. Let's try another one. Water and CO2, what happens if it gets mixed? Oh, I need to. So imagine I have a webcam and I'm like a table and I'm drawing in real time and we could play with it, but it's very interactive. Let's try this one. The Earth is being hit by something. Hopefully not. Let's add one more arrow and see what happens if we do that. Ah, that was fun. So it finally understood it was the moon. Let's play with the math one. And solve the expression inside the parentheses. Okay, so I have one where I did. Okay. Solve the multiplication with the parentheses. And let's assume I've done that too, and I have the next question. I need a better background for this demo, that's for sure. The first step is to simplify. No, go back. Okay, so any number divided by itself equals 1. But you see, it doesn't give me the answer. It just gives me a question so I can keep trying, right, and learning. Let's try one more complicated. Let's look at 4 on the axis. Oh, I was hoping it would give me a better question. Yeah, so the last one is the one that is encouraging curiosity. So this one, what is the lady doing? Okay. What are the colors on the flag? What shape is the star? Oh, it asked me things about Jordan. Let's see what it does with Apple. It has that. Do you know what Apple this is? Let's see. What does the apple smell like? I had a nice origami thing as well. Okay. I don't know where the origami went, but. So you sort of get the gist. These are like, I don't know, do you want me to draw something, or do you want to ask one of a question of the science or math or objects? Any requests from the audience? Don't be shy. Yeah? What should we ask? No? Okay. Well, excuse me? A system equation, yeah. Can you tell me what to write? 2x plus 7 equals 2. Thank you. Let's try it. Let's see if it does well with my subtract 7 from both sides of the equation. Not bad. And now if I do that, divide both sides by 2, and so on and so forth. Now, the cool thing about this, like I made the code open source and template so you can play with it too, is less than 100 lines. You just need to create an API key, which is free, and you can create your own instructions. And hopefully I inspired you to think like beyond of chatbot interfaces and delegating instructions and delegating like questions, and think more in like a tinkerer and think about how we could put these tools in the hands of young people because they are the future and they need to learn about this technology as well and how it works. I think that's my time. All my research is on my website, and I put a QR link for that as well, and I look forward to your questions afterwards. Thank you so much.
And next, we're excited to have Quinda, Halman, Kramer talking about building voice AI agents.
Thank you. So my name's Quinda. I work at a company called Daily. We make real-time audio and video infrastructure. And when GPT-4 was released last year, we started building lots and lots of experiments. We thought GPT-4 was so good at conversational exchange in text that it really should be able to talk to you, literally talk to you with your voice. So we built a bunch of things like this. This is probably a year ago, and in Gen AI terms, it's ancient history, but probably worth looking at as context.
I'm your friendly chatbot, here to assist you with any questions or tasks you have in mind. How can I help you today?
Can you tell me a joke?
Absolutely. Why don't skeletons fight each other?
You always start with that one. Give me a different joke.
All right, I'll give it another go. What do you call fake spaghetti?
I've heard that one too. Come on, maybe just...
So we use Tell Me a Joke from very early on all the way through today, and I think we know all the jokes that all the LLMs we use regularly tell, which is funny, but not necessarily funny in the same way they were the first time we heard them. So this is sort of a really high-level schematic of what we're trying to do here, right? We've got a user on a phone or a laptop. They want to talk to their device, and then somewhere in the cloud, we've got a bunch of GPUs that are doing a whole lot of heavy-duty compute, and we need to talk to those that cloud computing resource somehow. So as soon as you build stuff like the video we just saw, a couple of things come very much top of mind. One is speed really matters, and the other is architectural flexibility is really, really important. I'll talk about both of those things today. Let's start with architectural flexibility. So that really nice clean diagram gets really messy really fast. This is not unusual in an engineering software development problem domain, but I thought I'd kind of make a slide based on, I looked at a bunch of source code. I thought about all the conversations I've had with my colleagues and our customers and friends who are building this stuff. And it turns out you have to, at some level, kind of be aware of a bunch of these things if you want to build real-time, robust voice AI stuff, deploy it, and scale it to production. It's a little bit of an intimidating map. We're definitely putting the multimodal AI here, all the way from audio processing, things like echo cancellation, and CPU management when you're encoding and decoding audio and video, through networking issues like firewall traversal, all the way through to building things like retrieval augmented generation and tool calling so that your real-world applications are really, really useful. We can collect that kind of messy map into a little bit more kind of high-level categories. It's worth going through these just really quickly because I think they give you a sense of what that map is. So you need really robust and low latency media processing and transport. You've got to encode the media, you've got to send it over the network. That's got to work really well, it's got to work really fast. You need really good and fast transcription, at least until the future of truly multimodal audio native models comes, which will happen at some point. And even after that, you probably are going to need to go from audio to text for lots of kinds of AI use cases. You have to do lots of real-time data pipeline and buffer management. So I think in Discord, I've probably maybe 20 or 30 times answered the question, why is my audio stream not working, when I did local development on my Mac and then I pushed it to an Intel box in the cloud. And it's because Indian issues always get you if you're writing low-level audio stuff. But there's a lot of sort of pipeline and buffer management that comes into play here. You want to be able to swap between models for a whole bunch of reasons or use multiple models together. You generally need to call out to external systems. You have to do things like phrase endpointing, which is the fancy academic term for when is the person done talking and when do they expect the AI to talk. You need to handle interruptions really gracefully, and that actually is a whole rabbit hole of its own. People will interrupt the bot, and you need to figure out what you're going to do and how you're going to handle that and how you're going to maintain state when people interrupt. You have to do echo cancellation unless you can convince everybody in the world who's using your thing to wear headphones 100% of the time. And I've been doing audio-video development on the internet for a really long time. Like our core product at Daily is a WebRTC tech stack, so I can tell you that you will not convince everybody in the world to wear headphones all the time. Maybe if you're only deploying to people in like a call center professional context, but even then, it's pretty tough. And you need good, fast text-to-speech or voice generation on the other end. The good thing is, it's a lot, but when it all comes together, it really is amazing to build with these new Gen AI tools. You can build stuff that feels magical and new to people, but that is genuinely useful, that sort of just feels like how things should be. This is an example of something we built for a healthcare customer that solved a real pain point. I think if you've been to the doctor, which I'm sure all of us have, you've had to fill out way more forms than you thought you should at subsequent doctor visits. And maybe you filled those out on paper, maybe you got a link to a form to fill out before the visit, which is like the current state of the art. What if an LLM could just call you on your phone, or you could click a link in an app and you can have a conversation and you never had to fill out a form again?
Hello, chat. My name is Jessica and I am with Tri-County Health Services. To ensure your privacy and to confirm your identity, could you please provide me with your birthday, including the year?
Yeah, it's January 1st.
I appreciate that, Chad. Can you also tell me...
Oh, sorry, yeah, 1983.
Thank you for providing your birthday, Chad. Now, could you please list your current prescriptions, including the medication name and the dosage for each?
Yeah, I take lisinopril and also gabapentin.
Great. Could you please provide the dosage?
Oh, yeah, sorry, 10 milligrams and 100 milligrams respectively.
Thank you for that information, Chad. Additionally, do you have any allergies that we should be aware of? If so, please list them.
Yeah, I'm allergic to latex and I'm also allergic to penicillin.
Thank you for letting us know about your allergies, Chad. Next, are there...
So I think you can see how all those pieces we just talked about are actually necessary to pull together something like that. But when you do, it feels simple. It feels like it's supposed to. That's a real video. Nothing in there is edited. The callouts to the external system are mocked. There's not actually a real electronic health record systems on the back end, but they're real tool calling. And that stuff is now starting to move into production in the real world. So I think in a lot of cases, the Gen AI frontier is moving very quickly, and people are really sort of pulling it out of our hands, which is super exciting. So let's switch gears a little bit and talk about fast, because that's the other really big piece here. How fast do we need? How fast is fast? And also just a quick side note. So we're talking, there are always two kinds of fast when you're talking about engineering things. There's throughput and there's latency. These days, for conversational interactions, throughput is pretty okay for all the tools we all use today. Like LLMs and other tools can generate content as fast as people can read it or listen to it. But what's hard is latency, and latency is that sort of time to first byte, time to first token. In lots of engineering contexts, there's trade-offs between throughput and latency, complicated relationships between throughput and latency. One of the graphs that I sometimes show in these talks is that throughput tends to improve by an order of magnitude every couple of years in lots of domains. Latency improvements tend to be linear and like way behind throughput improvements. So latency's hard, and latency's mostly what bites us here. Human conversational latency, like if I am talking to another person, it feels weird to me if that person doesn't respond in about half a second. Sometimes people respond actually a lot faster. We seem as humans to be doing like speculative decoding, next token prediction, just like natively. Like that's what we do. I know what you're gonna say 4 or 5 words before you finish saying it. I'm queuing up my response. I'm sort of doing my inference in this like greedy fashion. If you say something I didn't expect, well, I can like reroute. But most of the time I'm right. And most of the time, if you actually record people in conversation, they'll respond in like 200 or 300 milliseconds commonly. And if they don't, they'll give you some kind of cue. So the sort of 500 millisecond target is pretty important, because we hit that uncanny valley pretty quickly when we're above it. In fact, I think that video of my colleague Chad that you just saw, if you watched it with a critical eye, what I hope you saw was pretty cool orchestration of like state-of-the-art Gen AI stuff, and probably slower response times than really should be there. So we spent the last couple months, I've spent the last couple months really sort of thinking a lot about how to improve these response times. And just as a kind of benchmark, or like relative, like another number that shows how hard this is, like Gemini Pro's time to first token, it's like 900 milliseconds. So if you're aiming for 500 milliseconds, you're already almost double even before you do anything else, even before you send stuff, you know, over the network for other services or anything. So what models and tools you choose are constrained. They matter a lot. It matters a lot how you string them together. So just to pop up a level again, this is what we're trying to achieve. And the most powerful tool we have today for making everything run fast in this domain is actually putting as much together into one compute container as we possibly can. So if the really, really big things we're trying to do are natural language, speech to text, and then phrase endpointing, so when should the bot do processing or talk, and then LLM inference, and then voice output. If we can put all those things together and run them locally and co-located, we're like way ahead of where we are if we can't do that. And this is worth emphasizing because I'm sure like 95, 98, 99% of stuff we're all building today with Gen AI, we're calling out to hosted services. There's a lot of really, really good reasons for that. But that's tough in this domain if latency is what you're prioritizing. And latency might not be what you're prioritizing, and that's okay. Like there's lots of different trade-offs you can make, but if you're trying to make things really, really, really fast, you need to figure out how to host stuff yourself and how to host stuff in a way where you can tune and control and combine everything. So this is the part of the talk where I like look at the clock and I look out at all of you and I try to figure out how much tolerance you have for me talking about latency, because I will, maybe ironically, we'll talk about latency for hours and hours. It's what I'm obsessed with as an engineer. I do think it's worth just quickly kind of going over this list of like kind of the best you can hope for latency numbers for a typical voice AI context, because some of them are non-obvious. So first, what are we actually measuring? We're measuring the time, like what do we really, really care about? We measure the time I stop talking. So if there's like a green waveform on one side and a purple waveform on the other side of this like, you know, audio editor, the time I stop talking, and then there's some kind of gap, usually silence. We could play hold music if it's too long a gap. And then there's another waveform on the other side when I first start to hear the LLM talking to me. That's the gap we care about, the voice-to-voice latency. And that has to include everything. It has to include audio encoding, sending stuff over the network, all the processing, sending stuff back, playing it out the speakers. The very first number here is actually kind of shockingly high. If you're using the laptop mic on Mac OS, it's like 30, 40 milliseconds of delay. There are some good reasons for that. There's a lot of audio processing, again, echo cancellation, background noise removal, gain control, all that stuff plays a role here. As these kind of use cases get more and more important, maybe hardware and operating system manufacturers will push this stuff down. But today, you're sort of 40 milliseconds into your 500 millisecond target time before the bytes ever even get into any of what we think of as software we control. And then you're encoding the audio, you're sending it over the network, you're doing some packet handling, you're reassembling those packets on the other side in what we call a jitter buffer, you're decoding, and then you're finally at the transcription stage. If you are really careful about transcription and endpointing, you can probably get down to a couple hundred milliseconds. Then you're doing LLM inference. In this context, you're really hoping you can get your time to first token from the LLM in maybe another 100 milliseconds. Then you're doing some text to speech, and then you're going over the network and out the other side. These are real measured numbers, sort of medians. There's obviously some hand waving because it's hard to measure everything perfectly and there's huge amounts of variation. But you're at like 600 to 700 milliseconds, optimistically but realistically in this world. So that gives you a sort of sense of where we are. Yesterday, we posted a demo on Twitter of really trying to drive all this latency down. And we have like a container that's open source that you can kind of look at and play with and hack on that gets you to like the 500 to 700 milliseconds of latency.
Hello, I'm FastBot. How can I help you today?
Let's play a geography game. Do you want to give me some geography questions to answer?
That's the spirit. I'll give you a question. What is the world's largest desert?
Oh, I think it's the Sahara.
That's correct. The Sahara Desert is indeed the largest hot desert in the world, covering most of North Africa. Well done. Next question. Which river is the longest in South America?
It's got to be not the Nile, sorry, the Amazon.
No need to apologize. You're absolutely right again. The Amazon River is indeed the longest river in South America and one of the longest rivers in the world. Good job. Next question. What is the capital city of Australia?
Canberra?
Correct again. Canberra is the capital city of Australia. You're on a roll. Next question. Which mountain range runs along the border between France and Spain?
Pyrenees?
Exactly right. The Pyrenees mountain range does indeed run along the border between France and Spain. You're really showing off your geography skills here. Next question. What is the largest city in Scandinavia?
Visit Stockholm?
I think there might be a slight mistake. Visits.com is not a city, but rather a travel website.
I was trying to say Stockholm.
No worries. I knew what you meant, and you're absolutely right again. Stockholm is indeed the largest city in Scandinavia and the capital of Sweden. You're doing great. Next question. Which city is the largest in Poland?
Krakow?
Close, but not quite. Krakow is a beautiful city in Poland, but it's not the largest. The correct answer is Warsaw, which is the capital and largest city of Poland.
Oh, I feel like I should have known that. If we're going to talk about capitals, maybe I'll ask you some questions. What's the capital of France?
I'm ready for a challenge. The capital of France is Paris.
Germany?
Not quite. Well, Germany is a country
No,
with
I meant what's the capital of Germany?
Good one. The capital of Germany is indeed Berlin.
And what's the capital of Stockholm? What's the capital of Sweden?
No worries. The capital of Sweden is Stockholm.
So the idea there was not to do prompt engineering, because clearly I could have done a better job on prompt engineering, but to kind of really test latency and show all the latency numbers in one place, because it's useful to visualize stuff. And again, that UI and everything is open source. So the big number in the middle is the voice-to-voice latency measured on the client side, and then the numbers on the edge are metrics that are being sent from the server that's doing all that work, sort of on the individual pieces, the measurement sent back, so you can sort of see what the variation is and correlate and kind of get good intuitions about this stuff. The architecture here is 2 models by a company called DeepGram for the transcription and the voice generation that are really good compromises between how good they are and how fast they are. And DeepGram has a hosted service, but they also let you run those models on premises in little Docker containers. And that's Llama 3 8B, I think, because I couldn't quite get 7dB to run as fast as I wanted it to, although in theory that's possible. And I'll post some links to this if you want to look at it more. So because we solved so many problems over and over, we thought it would be great to have an open source framework for this stuff. I think we've seen this in other parts of AI landscape. Things like LangChain and Llama Index are really valuable. This is sort of that for real-time and multimodal AI. And this slide probably looks familiar because I stole the list of hard problems from this slide and made a slide that I moved higher up in the talk here for today. But this is an open source framework called PipeCat. It's gotten a bunch of traction recently. It's vendor neutral, even though it came out of work that we've done at Daily early on this. And we're just really excited about this. It's super fun to be getting lots of community contributions now. And if you are trying to build really fast multimodal AI stuff, I think it's at least worth taking a look at. You can build things like conversational bots and speech-to-speech language translation apps and voice-controlled agents of various kinds, like that control your software user interfaces, and real-time vision model stuff, like the awesome last presentation, is also like baked into PipeCat services now. Here's all the stuff that's supported in PipeCat today. We're adding stuff all the time. You can add stuff. So if you're interested in building, please hang out with us in the PipeCat Discord. If you want to contribute a service plugin, please do that. If you want to be a maintainer for an open source project that's a lot of fun, ping me. Maintainers are, gold in the open source world. We're all always trying to recruit great maintainers. And just last slide about the context here. So this is the PipeCat star rating list, and the day that it went vertical was the GPT-4o announcement. We're gonna get great multimodal models, and they'll be incredibly useful. They'll make building super fast stuff easier and easier. But A, they're not here yet, and B, we're still gonna need orchestration layers for all this stuff. Also, the demo that I showed just a minute ago that I posted yesterday is now at 175,000 views on Twitter. So there's more and more and more interest in voice AI, and we'd love to have people come build with us.
Awesome. Thanks so much, everyone, for joining us for the multimodal track. And that is the end of the sessions today.
Push. doors that open for us in a moment. Keeping the light on, righting our old wrongs. Keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all of us. We can feel it, chasing the light is all we know. See in the forest, for the trees I'm keeping watch. All that is storming, waking up and turning on, keeping the light on, righting all the wrongs, keeping our sights on everything we want. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all of us. We can feel it, chasing the light is all we know. We catch our breath in the middle of it all, chasing echoes. Sun is coming up over us, it's coming. Crystal vision. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. I can see on the horizon all of us. We can feel it, chasing the light is all we know. Chasing the light is all we know. Can't stop and I won't let it go. Chasing the light is all we know. Can't stop and I won't let it go. Like a fever, burning up, yeah, we're on fire. True believer, we're walking on the wire. taking one more breath beside you, so I could find strength to divide us. Gave it all we got, and I know we did the best we could. If I could go back, undo the mess, I would memorize your face before I go. But this is how we go. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we go. Sometimes we hold on to let go. Sometimes we hold on to let go. Sometimes we hold on to let go. There is nothing lost between us. And oh, I know you have your reasons. Some days I'm a mess, but I know there's a rainbow over all of the past. Your head on my shoulder, but I know we're better on our own. But this is how we go. Gotta give it up, sometimes it's gold. And knowing when to kill your pride. There's no one to blame, nothing really stays the same. This is how we go. Sometimes we hold on to let go. Sometimes picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Because I'm missing you. I was chasing all the wrong signs, trying to hold on to something that I couldn't find. Wish you didn't captivate my mind. Now I know we've in the sunsets of paradise, but now something went wrong. You're moving on. I found myself on the blind side. Now you won't call. We lost it all. You fade away. I'm picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Because I'm missing you. Oh, because I'm missing you. Because I'm missing you. Because I'm missing you. Picking up my heart from every piece that's broken. Been trying to get back to myself, but don't have a clue. I'm looking for some luck, can't find a door that's open. I'm losing all my hope, feels like I'm left here in two. Because I'm missing you. Tell me that you wanna stay, baby, just don't walk away. I need you now, fade it out. All the time we spent alone, fighting through the firestorm. Don't let me down, I need you now. Cause I'm feeling worn out, it's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading our broken dreams. I wanna be next to you, 'cause I'm feeling worn out. It's getting to me. Lost some heart trying to get on my feet. Caught in the madness, I feel you somehow. Don't let me go, I need you right now. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you, you wanna be next to me. Holding our paper hearts, fading out broken dreams. I wanna be next to you. We got an insomniac with eyes wide shut, and we got everything we need and then a little too much. I know that you're starving for something you can't touch. Would you be honest with me right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna? Don't you wanna? Think there's something in my bag that's weighing me down. Oh, it's just the weight of the world. Now I'm calling it out. We're a little starving for some lightning love. Can we speak honestly right now? There's something in the undercurrent, I can feel it coming up. Don't you wanna feel it? Taking over your senses. Don't you ever fear it? Technologic advances. Baby, come escape with me. I'll come sweep you off of your feet. Don't you wanna feel it? Don't you wanna? Don't you wanna? Holding my breath and I'm ready to go. I'm falling right in and I'm ready to go. I found what I want and I know that we're on top, so I'll tap in and I'm ready to whoa. Holding my breath and I'm ready to go. I catch you laughing and I'm ready to go. You're holding the match, strike it and ignite my soul. I'll tap in and I'm ready to whoa. We are a summer storm. Feeling you can't ignore. Do you ever stop to feel it caught in the after?
Ladies and gentlemen, please return to the ballroom to take your seats for our afternoon program. We will start our program in 10 minutes. Thank you.
As we give up our
Ladies and gentlemen, our program begins in 5 minutes.
Taking one more breath beside you.
Ladies and gentlemen, please take your seats. Our program is about to begin. Thank you. Ladies and gentlemen, please welcome to the stage Head of Developer Experience at OpenAI, Roman Hewitt.
Wow, good afternoon, everyone. Super excited to see you all here today. Such an incredible energy here. I'm Romain, I lead developer experience at OpenAI. And before joining OpenAI, I was also a founder. And like many of you in this room, I actually experienced firsthand the magic of building with the frontier models. Now I'm working on making sure we offer the most delightful experience for all of you builders in this room. And what I love the most about this role is also showing the art of the possible with our AI models and technologies. And so today, we're going to go through a few things that the great capabilities that the OpenAI team has built recently, and we'll show some live demos to really bring them to life. But first, I'd like to start with a quick zoom out on how we've gotten to where we are today. OpenAI is a research company, and we're working on building AGI in a way that benefits all of humanity. And to achieve this mission, we believe in iterative deployment. We really want to make the technology enter contact with reality as early and often as possible. And for that, a top focus for us at OpenAI is really all of you, like the best builders in the world. We really believe strongly that the best developers and startups are integral to the G in this like AGI mission. You guys are the ones that are going to build the native AI products in the future. So today we have 3 million developers around the world building on the OpenAI platform, and we are very fortunate to have so much innovation. But I'd like to rewind a little bit. And you know, today outside of this room, when people think of OpenAI, they often think of ChatGPT first, because that's become like the product that has taken the world by storm a little bit. But the first product was actually not ChatGPT. The first product we put out there was the developer platform. So back in 2020, at the time, we had GPT-3, and that's when we first started launching it to the public behind an API. Maybe a quick show of hands, actually. Who in this room have played with the API at the time of GPT-3 already? Wow, that's like more than half of you. You guys are really my crowd here. That's awesome. And you know, at the time, we kind of got a taste for what AI would be capable of doing, like basic coding assistance, copy editing, maybe some very simple translation. But to really put things in perspective, at the time, this was the most, or one of the most popular use cases on the platform. AI Dungeon. This was like a role-playing game purely based on text. And it kind of was generating open-ended stories, and you could navigate the world, and you know, at each scenery, when you were trying to look around, it would generate new text. So that was kind of the state of the art at the time. Obviously, in 2023, GPT-4 changed the game. It completely changed the way we thought about AI. It got better at reasoning. It got more creative, more specific. It could start being better at coding and reasoning about complex problems. And it could use tools also, interpret data, and kind of that dramatically expanded the aperture of the possibilities with the platform. We've had the great fortune of working with many, many developers and companies like integrating GPT-4 in their own apps and services. And this is just one example among many. Spotify, when they took our models to kind of generate playlists on the fly based on your music taste and history. But the one thing I want to highlight today in this talk is that GPT-4 was also the beginning of our multimodality journey. This is the very first time where we introduced like vision capabilities, and suddenly GPT-4 could analyze and interpret data such as images, photos, etc., not just purely text. And then with GPT-4 Turbo, for the first time, we brought vision capabilities into the same model right inside, so that you can have the exact same model that does the two modalities at the same time. And of course, last month, we kind of took a step further with multimodality, and that brings us to GPT-4o. So GPT, new flagship model that can reason across audio, video, and text all in real time. And thanks to its native image and audio capabilities, we really think that you can now build very natural human-computer interactions in a way that we've never seen before. And so the reason we call it GPT-4o is because O is for omni model, if you will. And that's because we brought all of these modalities into one single model for you to interact with. And there are like many things that are very unique and interesting about GPT-4o, but I'd like to call out a couple step function changes here. The first one is that it's really a big step towards like this multimodality future with like ultra-fast latency. For the first time, like I'm not sure if many of you have played with ChatGPT with voice mode before, or if you've tried to build your own voice assistants, but you kind of had to stitch kind of three models together. First, like Whisper for translation, then GPT-4 for reasoning, and then ultimately text-to-speech. But of course, that kind of added a loss of context and some latency along the way. Now we have all of that into a single model. And for all of you developers, what's really exciting too is that for the same kind of state-of-the-art reasoning capabilities that we offer with GPT-4, we also ship massive efficiency improvements. And that means that in turn, we've been able to turn those efficiency gains back to you. So as a result, GPT-4 is twice as fast as GPT-4 Turbo. It's also half the price. And we also increased drastically the rate limits. I actually have like 5x higher rate limits on this slide, but we are kind of like always pushing them higher, and we really want to live in a world where there's not even any rate limits, so you can build with no limits. But with all that said, I'd like to give you a glimpse into GPT-4o, and so we're going to switch over to my Mac here. So for this first live demo, I'm going to bring up ChatGPT for desktop. And all I have to do is click Option space, and I'm going to bring the voice mode right here. Hey, ChatGPT, how are you?
Hey, I'm doing great. Thanks for asking. How about you?
I'm great. I'm actually on stage at the AI Engineer World's Fair in San Francisco. Could you greet the audience? We have some amazing developers here in the room.
Hey, everyone. It's awesome to be virtually here at the AI Engineer World's Fair in San Francisco.
So ChatGPT, I kind of like how you started, but I really want you to bring the energy. Like, people are very excited here, so make this more alive. And also, don't forget, people are also tuning in from the live stream, so don't forget about them.
Hello, San Francisco, and to everyone joining us on the live stream. Welcome to the AI Engineer World's Fair. We've got an incredible lineup and a ton of energy here today. Let's dive into all the exciting tech and innovation.
That's much better. Thank you, ChatGPT. I think they really enjoyed that.
Here. If you need anything else, just let me know. Hope the event goes fantastically.
Yeah, maybe one thing you could do, like, since we have a crowd of the best builders out there, can you whisper one secret that's really precious, but as they're building the future of their AI native products? What should they know?
All right, just between us, remember, the key to building great AI native products is focusing on responsible and ethical transparency and glad you liked it.
Can you whisper another one, but even lower, like very, very, very slow?
Sure. Here's one more. It's crucial to keep your AI adaptable and scalable. Technology evolves fast. Your products should too.
Cool. So thank you. A couple of things to call out here, but first of all, like, you can see the latency is pretty impressive. Like, it's very much like natural in a conversation, and there's really no difference with talking to humans. It's almost too fast at times, I would say. The second thing that's really cool is, like, it understands emotion and can generate tones. You know, it could whisper, it could bring the energy, it could be more alive, but also I can jump back in the conversation at any time. I can interrupt the model, and I don't have to wait for the kind of audio output to finish. And that's really cool to have something much more natural versus what we knew before. So the next thing I'd like to show you, of course, we're talking about modalities. So let's bring the second modality. I'd like to turn on camera here.
Anytime.
Hey, ChatGPT, can you now see me?
Yes, I can see you.
Yeah, you know, you don't have to whisper anymore. You can talk normally now.
Got it. How's the event going?
It's good. Do I look good, actually? Because I'm in front of a lot of people here.
You look great. Ready for the spotlight.
Awesome. Okay, so give me a second. I'm gonna try to draw something for you, and I'll show it to you.
Sounds good. I'm curious to see what you come up with.
Just give me a few more seconds, you know.
Take your time. I'm here whenever you're ready.
Luckily, ChatGPT is pretty patient, so that's good.
No rush. I'm always here when you're ready to.
Okay, so based on what I drew here, can you take a guess at where I am? And also, can you translate what I wrote?
Yes. That's the Golden Gate Bridge, so you must be in San Francisco. And you wrote, Bonjour, développeur, which means hello, developers, in French.
Pretty cool. All right. This was a pretty poor bridge, but ChatGPT is pretty clever. Next, I have this book. Can you take a look, ChatGPT? What is this?
Yeah, that's Poor Charlie's Almanac by Charlie Munger. It's a collection of his speeches, talks, and life philosophy. Munger is known for his wisdom on investing and decision-making.
Yeah, can you just give me a random number between 1 and 400?
Sure. How about 126?
126, here we go. Okay, page 126. Can you give me like a brief overview of what's happening on this page?
It looks like this page talks about Coco Chanel's rule for success. It mentions that Chanel focused on identifying the qualities her customers wanted and made sure to offer them. Essentially, understanding your audience desires is key to success. Would you like a bit more detail from the page?
No, I think I'm good. This is pretty amazing. You read faster than I could read just one line, so it's pretty amazing. All right, cool. Next, I'd like to show you something else. So instead of camera, I'll go real quick here, and instead of sharing camera, I'll share my screen. So I'm going to bring up ChatGPT one more time here with audio capabilities. I'm going to reduce this window a little bit. So
Can you clarify?
Okay, ChatGPT, I'm going to share my screen with you. Can you see what I see?
Yes, I can see your screen. What are we looking at here?
Well, I'm currently working on this app. It's a travel app, and I'd like to make it a little better. But there's one thing that I'm not quite sure about doing, and I'd like your help. So if I go to this tab here, and if I try to put the final touches on it, it feels like the responsiveness is not really good. Like, what do you think?
I see what you mean. When you switch to the mobile view, the layout looks a bit cramped and the images seem squished. Have you considered using media queries to adjust the layout for smaller screens?
So let's take a look at the code here. Maybe you could help me. I'm going to send you first like this whole component. I'm going to copy the code over to you if you can take a look. Can you give me like a one-line overview of what's going on in that one?
This code defines a React hook, use assistant, that manages interactions with an AI assistant. It handles sending and receiving messages, file uploads, and streaming responses from a server.
Okay, cool. I don't think that's where we need to change some stuff. I think it might be over here in the Discover component. What do you think?
Yeah, it does look like this is where the layout is being set for those end descriptions.
So I'm using Tailwind CSS. What should I do exactly to kind of change it and make it responsive here?
You could adjust the grid color attributes on mobile sizes by using mobile.
What's the kind of prefix I should use for mobile screens then?
You can use the SM prefix for small screens.
Okay, try that. If I say this, and maybe for other, is that looking right? Like medium screen, maybe 2, and then we keep the 3 for large screens, something like that?
Yeah, that looks good.
Okay.
Adjusting the color.
Oh, take a look now. What do you think?
It looks much better. The
Awesome.
images and layout. Great job solving that. Anything else you want to tweak?
So I really like using ChatGPT on desktop as a coding assistant. But of course, this was a very trivial use case. But what's also even more interesting is when you start reasoning out loud with ChatGPT to build something, but you also tell like, hey, actually, I'm going to get Cursor to do it, but what should I prompt Cursor? And I've done that many times. It's also pretty amazing to see how both of them can interact across modalities. But let's go back to my presentation, please. I'd like to give you a little bit of a sneak peek of what's on our mind. What are we working on next at OpenAI as we think about these modalities and the future of models? So there are 4 things that are currently top of mind for us, especially for all of you developers building on the platform. The first thing is textual intelligence. Of course, as you can tell, we're extremely excited about modalities, but we also think that increasing textual intelligence is still very key to unlock the transformational value of AI. And we expect the potential of LLMs, intelligence, we expect that potential to be like still very huge in the future. Those models today, they're pretty good, as we can tell, we're building things with them. But at the same time, what's really cool to realize is that they're the dumbest they'll ever be. We'll always have better models coming up. And if you will, it's almost like we have first graders working alongside us. They still make mistakes every now and then. But we expect that in a year from now, they might be completely different and unrecognizable from what we have today. They could become master students in the blink of an eye in multiple disciplines like medical research or scientific reasoning. So we really expect the next frontier model will have such a function change in reasoning improvements again. The second area of focus that we're excited about is faster and cheaper models. And we know that not every use case requires the highest intelligence. Of course, GPT-4's pricing has decreased significantly, 80% in fact over a year, but we also want to introduce more models over time. So we want these models to be cheaper for you all to build. We want to have models of different sizes. We don't really have timelines to share today, but that's something we're very excited about as well. And finally, we want to help you run async workloads. We launched a couple months ago the Batch API. and we're seeing like tremendous success already, especially for those modalities. Say you have like documents to analyze with vision, or photos or images, all that can be batched for another 50% discount on pricing. Third, we also believe in model customization. We really believe that every company, every organization will have a customized model. And we have like a wide range of offering here. I'm sure many of you here have tried our fine-tuning API. It's completely available for anyone to build with. But we also assist companies all the way, like Harvey, for instance, a startup that's building a product for law firms, and they were able to kind of customize GPT-4 entirely on US case law, and they've seen like amazing results in doing so. And last, we'll continue to invest in enabling agents. We're extremely excited about the future of agents, and we shared a little bit about that vision back in November at Dev Day. And agents will be able to perceive and interact with the world using all of these modalities just like human beings. And once again, that's where the multimodality story comes into play. Imagine an agent being able to kind of coordinate with multiple AI systems, but also securely access your data and even, yes, manage your calendar and things like that. We're very excited about agents. Devin, of course, is an amazing example of what agents can become. Like Cognition Labs has built this awesome software engineer that can code alongside you, but he's able to break down complex tasks and actually browse the documentation online, submit pull requests, and so on and so forth. It's really a glimpse into what we can expect for the future of agents. And with all of that, it's no surprise that, in fact, Paul Graham realized a few months ago that like often 22-year-old programmers are often as good, if not better, than 28-year-old programmers. And that's because they have these amazing AI tools at their fingertips. So with that, I'd like to switch to another demo to kind of show you this time, not ChatGPT, but rather like what we can build with these modalities. So in the title of this talk, I did not mention video, but I'm sure most of you have seen Sora, the preview of our kind of diffusion model that's able to generate videos from a very simple prompt. And this is one of them. So in the interest of time, I've already sent this prompt to Sora, describing a documentary with a tree frog, very precise on what I'm expecting. And if I click here, this is what came out of Sora. It's pretty cool. But next, what I'd like to do is kind of bring this video to life, and here what I'm doing is like I simply sliced frames out of the video of Sora, and what I'm going to do next is very simple. I'm going to send these 6 frames over to GPT-4o with vision with this prompt, if you're curious, and I'm going to tell it to narrate what it sees as if it was a narrator. So going back here, I'm going to click Analyze and Narrate. Again, this is all happening in real time, so every single time the story is unique, and I'm just discovering it like all of you. And boom, that's it. So that's what GPT-4o with vision was able to create based on what it saw in those frames. So it's pretty magical. But last but not least, I wanted to show you one thing that we also previewed recently, and it's our voice engine model. The voice engine model is the ability for us to create custom voices based on very short clips. And of course, we take safety very responsibly, so this is not a model that's broadly available just yet, but I wanted to give you a sneak peek today of how it works. And also the voice engine is what we use internally with actors to bring the voices you know in the API or in ChatGPT. So here I'm going to go ahead and show you a quick demo. Hey, so I'm on stage at the AI Engineer World's Fair. I just need to record a few seconds of my voice. I'm super excited to see the audience that's really captivated by these modalities and what we can now build on the OpenAI platform. All right. Hey, so I'm on stage at the sounds like Engineer World's Fair. I just yeah, sounds like it's perfect. That's all we need. So now to bring us all together here, what I'm going to do is I'm going to take this clip. I'm going to take the script that we just generated, and I'm sending all of it back to the voice engine, and we'll see what happens. In the heart of the dense, misty forest, a vibrant frog makes its careful way along a moss-covered branch. Its bright green body, adorned with striking black and yellow patterns, stands out amidst the lush foliage. Now, I can also have it translate in multiple languages, so let's try French. Au cœur de la dense forêt brumeuse, une grenouille vibrante fait son chemin avec précaution le long d'une branche. And for those who know me, that's actually how I sound when I speak French. Son corps d'un vert vif orné de motifs noirs et jaunes frappants ressort au milieu du feuillage. Maybe one last one with Japanese. En naviguant sur le chemin périlleux, les yeux de la grenouille restent vigilants. Chaque pas est délibéré, ses orteils collants lui fournissant une prise ferme sur l'écorce rugueuse en dessous. La branche se balance doucement. All right, thank you. Let's go back real quick to the slides. And of course, this is one very specific example of bringing modalities together with, Sora videos, GPT-4 and Vision, the voice engine that we have not released yet. But I hope this inspires you to see how you can kind of picture the future with these modalities combined together. So to wrap up, we're focused on these 4 things: textual intelligence to drive it up, making our models faster and more affordable so you all can scale. We're thinking about customizable models for your needs. And finally, making sure you can build for this multimodal future and agents. And if there's one thing I want to leave you off with today, is that our goal is not for you guys to spend more with OpenAI, but our goal is for you to build more with OpenAI. Because let's remember, we're still in the very early innings of that transition, and it's a fundamental shift in how we think and build software every day. So we really want to help you in that transition. We're dedicated to supporting developers, startups. We love feedback, so if there's anything we could do better, please come find me after this talk. And this is really like the most exciting time to be building an AI native company. So we want you to bet on the future of AI, and we know that bold builders like all of you are going to come up with the future and invent it before anyone else. So with that, thank you so much, and we can't wait to see what you're going to build with those new modalities and reinvent Software 2.0.
Ladies and gentlemen, please welcome to the stage the authors of What We Learned from a Year of Building with LLMs, Brian Bishoff and Charles Fry.
Hey everyone. So, you're about to experience something of a strange talk, and not just because Brian and I are strange, but because something kind of strange happened. Over the last year, a bunch of us were posting things on Twitter. We were writing blog posts complaining about LLMs, and we formed a little group chat. And we were, continuing to complain about LLMs to each other, and sharing what we were working on, when we realized we were all about to write the exact same blog post, what we learned in the last year. So we got together, and we turned what was initially a couple of short blog posts into a long white paper on O'Reilly, combining our lessons across strategic, operational, and tactical levels of building LLM applications. And the response to that white paper was overwhelmingly positive. We heard from everybody, from people who contribute to Postgres, to venture capitalists, to tool builders, saying, "We loved what you wrote in that article. I felt that pain too." And we were invited, on the strength of that, to give this keynote address. And so we faced a kind of funny challenge, which is part of the appeal of this blog post, of this article, was that the 6 of us all came together to write it. As Scott Condren put it, it was like an Avengers team-up. So we had to figure out a way to deliver one keynote talk from 6 people. So we pulled the Avengers together for one night only to sort of deliver some of the most important insights from that 30-page article, to add some of our spicy extra takes that ended up on the cutting room floor, and to respond to the allegations. I'd like to state unequivocally that we are not, in fact, crypto bros who just found out that GPT-4 was the new Web3. We all trained our first neural networks back when you had to write the gradients by hand. So we split the article up into 3 pieces, so we split the talk into 3 pieces. First, you're going to hear from me and Brian talking about the strategic considerations for building LLM applications. How do you look to the future? How do you see around corners? How do you make big decisions? Then we're going to hand the clickers and the stage over to Hussein and Jason Liu, who are going to share the operational considerations. How do you put together processes? How do you put together teams? How do you think about workflows around delivering LLM applications? And then they will hand over the clickers and the stage to Shrea, Shankar, and Eugene, who will talk about the tactical considerations for building LLM applications. What are the specific techniques, tactics, and moves that have stood the test of 1 year's time for building LLM applications? All right, so Brian, how do you build an LLM application without getting outmaneuvered and wasting everybody's time and money?
Yes. Well, many of you may be thinking that there's really only one way to win in this new, exciting, dynamic, and very scary industry. And that, of course, is to train your own custom model. Pre-training, fine-tuning, a little RLHF here and there. You better start from scratch, buddy. Not quite. The model is actually not your moat. For almost no one in this audience, the model is the moat. You all, as AI engineering devotees, should be building in your zone of genius. You should be leveraging your product expertise or your existing product. Maybe you've got one. And you should be finding your niche and digging into that niche, exploiting it. You should be building what the model providers are not. There's a high likelihood that the model providers have to build a lot of things for all of their customers. Don't waste your calories on building these things. The Sam Altman phrase of steamrolling is appropriate here. And you should be treating the models like any other SaaS product. You should be quickly dropping them when there's a competitor that's clearly better. No offense to GPT-4o, but Sonnet 3.5 looking pretty sharp. It's important to keep in mind that a model with high MMLU scores, that's not a product. 87% on Spider SQL, that doesn't automate all data requests, or even 87% of them. You can't sell human eval pass at 67. At least my GTM team doesn't know how. An excellent LLM-powered application is an excellent product. It's well-designed. It solves a job to be done. And it enhances your user. Why are we so excited about AI? Human enhancement. So what should you build if not all of these things? Things that generalize to smarter and faster models. Things that help you maintain your product's quality bar under uncertainty. And things that help you continuously improve.
Whoa, Brian, continuous improvement. That's my trigger phrase. The idea of continuous improvement has been brought to the world of LLM applications by this shift in focus that we've all felt since the previous AI Engineer Summit to focus on evaluation and data. It's nicely synecdocalized by this diagram from our co-author, Hussein, showing this virtuous cycle of improvement. It has evals and data at the center, but the core reason to create those evals, the core reason to collect that data, is to drive forward this loop of continuous improvement. And despite what your expensive consultants or many of the LinkedIn influencers posting about LLM apps might say, this is not actually the first time that engineers have tried to tame a complex system and make it useful and valuable. This same loop of iterative improvement was also at the core of ML ops, at the operationalization of machine learning models before LLMs. This figure from our co-author Shrea Shankar's paper had that same loop of iterative improvement centered also on evaluation and on data collection. MLOps was also not the first time that engineers faced this problem. The problem of complexity, the problem of non-determinism and uncertainty. The DevOps movement that gave MLOps its name also focused on this kind of iterative improvement and on monitoring information in production to turn into improvements to products. But, dear reader, DevOps was not the first time that engineers tackled this problem of uncertainty and solved it with iterative improvement. DevOps built on the ideas of the lean startup movement from Eric Ries that was focusing not just on building an application, not just on building a machine learning model or an LLM agent, but on building the entire business. And it used this same loop centered on measurement and data to drive the improvement and building of a business. This idea itself was not invented in Northern California, despite what some people might say. It has its roots in the Toyota production system and in the idea of Kaizen, or continuous improvement. Genshi Genbutsu is one of the core principles from that movement that we can take forward into the development of LLM applications. It means real things, real places. And at Toyota, that meant sending executives out to factory floors, getting their khakis a bit dirty. For LLM applications, the equivalent is looking at your data. That data is the real information about how your LLM application is delivering value to users. There's nothing that is more valuable than that. Finally, there's lots of people selling tools at this conference, including myself. It's easy to get overly excited about the tools and the construction of this iterative loop of improvement and to forget where value actually comes from. And there's a great pithy, earthy statement from the Toyota production system from Shigeo Shingo that I really like. Value is only created when metal gets bent. So we have to make sure that we don't get lost just building our evals and calculating concept drift, and we instead make sure that we continue to get out there and bend metal and create value for our users.
Not gonna lie, I might have misunderstood earlier when you said let's get bent. Okay, so right off the bat, we need to spin that data flywheel, Bob. Oh, wait, sorry, wrong game show. Point is, we need to get this moving. We need to get this in front of users and human beings. We need to express the goals for our system. And how do we do that? With evals. Remember, evals are not convenient, weird, bespoke metrics. Evals are objectives. They're what we want our system to do. Any system for capturing this behavior is good enough. I don't have an evals framework to sell you, but what I do have to sell you is this idea that you should be getting out there. You should be getting started. But wait, Brian, I'm really nervous. What if this isn't good enough for my customers? Fear is the mind killer. Put it out there in beta. If it's good enough for these incredible companies like Apple Intelligence, Photoshop, and Hex, that's me. It's good enough for you. You need to collect this data. You need to put something in the wild. You need to start looking at your user interactions. The real user interactions, LLMs, responses deserve human eyes. You can give it some AI eyes too, but definitely look at it with your human eyes. Binary human feedback is valuable. It's nice to add some rich feedback too. That can be interesting, but start with binaries. And finally, user requests will reveal the PMF opportunities that lie below your product substrate. Where is your PMF? Everybody wants to know. It's in your user interactions. What are they asking your chatbot that you haven't yet implemented? That's a really nice direction to skate if that's where the puck's going.
And despite the focus on the user interactions that you can have today, the things that you can ship right now, it's important to also think about the future. The best way to predict the future is to look at the past, find people predicting the present, and copy what they did. In designing many of the components of the personal computing revolution, Alan Kay and others at Park adopted as a core technique projecting Moore's law out into the future. They built expensive, unmarketable, slow and buggy systems themselves so they could experience what it was like and build for that future and create it. We don't have quite the industrial scaling information that Moore had when he wrote down his predictions, but we do have the beginnings of those same laws. There's been an order of magnitude decrease every 12 to 18 months at 3 distinct levels of capability. At the capability of DaVinci, the original GPT-3 API that excited a lot of us about the idea of building on foundation models. The capabilities of Text DaVinci 2, the model lineage underlying ChatGPT that brought the rest of the world to excitement about this technology, and the latest and greatest level of capabilities with GPT-4 and Sonet. In each case, around 15 months is enough time to drop the cost by an entire order of magnitude. This is faster than Moore's law. And so the appropriate way to plan for the future is to think what this implies for what applications that are not economical today will be economical at the time that you need to raise your next round. So in 2023, it cost about $625 an hour to run a video game where all the NPCs were powered by a chatbot. That's pretty expensive. In 1980, it cost about $6 an hour to play Pac-Man, inflation adjusted. That suggests that if we just wait for 2 orders of magnitude reduction, or about 30 months from mid-2023, it should be possible to deliver a compelling video game experience with chatbot NPCs at about $6 an hour, and people will probably pay for it. So you can't sell it now, but you can live it, and you can design it, and you can be ready when the time comes. So that's how to think about the future and how to think strategically when building LLM applications. I'd like to call to the stage my co-authors, Jason Liu and Hussein, to talk about the operational aspects. Let's give them a hand.
All right, thank you. All right, so Hal and I have basically been doing a lot of AI consulting in the past year, right? We've worked with about 20 companies so far, and we've done something from pre-seed all the way to public companies, and I'm pretty bored of giving generic good advice, especially because there's such a range of operators here. And so instead, I'm going to invert. My goal today is to tell you how to ruin your business. First of all, everyone knows that in the gold rush, you sell shovels. And so if you want to get gold, you got to buy shovels too, right? If you want to find more gold, keep buying shovels. Where do I dig? Keep buying shovels. How do I know when to stop digging? The shovel will tell you. And how do I dig one deep hole versus making investments in plenty of shallow holes? Again, the answer is more shovels, clearly, right? And this might be generic, so I'll give you some more specific advice. If your RAG app doesn't work, try a vector database, a different vector database. If the methodology doesn't work, implement a new paper. And maybe if you update the embedding model, you'll finally find product market fit. Because truth be told, success does not lie in developing expertise or processes. Try more tools. There's no need to balance between exploring and exploiting the mechanisms that work for you. Change the tools. And the processes and the decision-making frameworks don't matter. The right tool will solve everything. Number 2, find a machine learning engineer who can fine-tune as quickly as possible. A $2,000 per month OpenAI bill is very expensive. And instead, hire someone for $250,000, give them 1% of their company, to fight CUDA build errors and figure out server cold starts, right? Because what's the point of growing your company if you're just a wrapper? And if your margins are too low, try fine-tuning. It's much easier than figuring out how to build something worth charging for. It's really, I cannot reiterate this enough. It's very important to hire a machine learning engineer as quickly as possible, right? Even if you have no data, generating products. They love fixing Vercel TypeScript build errors. And generally, if you hire a full stack engineer who's really caught the LLM bug, they're going to lack real experience. And this is because Python is a dead language, right? Machine learning engineers research engineers can easily pick up TypeScript, and the ecosystem that exists in Python could be quickly re-implemented in a couple of weekends, right? The people who wrote Python code for the past 10 years doing data analysis, they're going to easily be able to transition their tools. And if anything, it's really easy to teach things like product sense and data literacy to the JavaScript community. And most important of all, in order to find this kind of magic talent, we need to create a very catch-all job title. Let's use words like ninja and wizard or data scientist or prompt engineer or even the AI engineer. In the past 10 years, we've known that this works really well, right? Every time we know exactly who we want. As long as we catch a very wide net of skills, it doesn't really matter whether or not we don't know what outcomes we're looking for. Anyways, to dig me out of this hole, I'll have Hamel explain and, take a deep breath, think out loud, step by step.
Thank you, Jason. So that was really good. I mean, let's just step back from the cliff a little bit. And let's kind of linger on the topic of AI engineer. I heard some booing in the audience. And so I love the term AI engineer. Like, much props to Swix for kind of popularizing this term. It allows us all to get together and have conversations like this. But I think that there's a misunderstanding of the skills of AI engineer, what skills you need to be successful, and there's a lot of inflated expectations. As a founder or engineering leader, your talent is the most important lever that you have. And so what I'm going to do is I'm going to talk about some of the problems and perhaps some solutions when it comes to this talent misunderstanding. So just to review, what is an AI engineer? So this is a diagram that everyone has probably seen. There's a spectrum of skills in the AI space, and there's this API dividing line in the middle. And kind of to the right of the API dividing line, we have AI engineer. The AI engineer skills are focused on things like chains, agents, tooling, and infra. And auspiciously missing from the AI engineer are tools like evals and data. And I think a lot of people have taken this diagram too literally and taken it to heart and say, hey, we don't really need to know about evals, for example. The problem is that you can go from 0 to 1 really fast. In fact, you can go to 0 to 1 faster than ever before with all the great tools out there, just by using vibe checks and implementing the tools that we talked about. However, without evals, you can't make progress. Quickly leads to stagnation, because if you can't measure what you're doing, you can't make your system better. And you can't go beyond 0 to 1. So what can we do about this evals, skill set, and data literacy? So Jason and I have found that you can actually get really good at writing evals and data literacy with just 4 to 6 weeks of deliberate practice. In fact, like very effective. And we think that these skills, evals and data, should be brought more into the core of AI engineer. And it really helps solve this problem. And it's something that we see over and over again. So the next thing I want to talk about is the AI engineer job title itself. And so vague job titles can be problematic. What we see over and over again in our consulting is that this kind of catch-all role have very inflated expectations. Anytime anything goes wrong with the AI, people look towards that role to fix it. And sometimes that role doesn't have all the skills they need to move forward. And we've seen this before with the role of data scientists. Titles and names really matter. And what I want to emphasize is I think AI engineer is very aspirational, and you should keep learning. And it's a good thing to strive towards. But you need to have reasonable expectations. And just to kind of bring it back to data science, we've seen this before in data science as well, where we had kind of a decade ago when this role was coined. It was a unicorn that had all these skills: software engineering skills, statistics, math, domain expertise. And we found out as an industry that we had to unroll that into many other different roles, such as decision scientist, machine learning engineer, data engineer, so on and so forth. And I think similar things may be happening with the role of AI engineer. And it's good to keep that in mind. And what I see, or what we both see in consulting, is that it's helpful to be more specific, to be more deliberate about what skills you need and at what time. And depending on your maturity, it's very helpful to not only specify what the skills are, but what kinds of products you'll be working on. So these are some job titles from GitHub Copilot that kind of are very specific about the skills you need at that time. And really, it's important to hire the right talent at the right time on the maturity curve. So when you're first starting out, you only need application development, software engineering, or AI engineering to go from 0 to 1. Then you need platform and data engineering to capture that data. And then only after that, you should hire a machine learning engineer. Do not hire a machine learning engineer without having any data. But again, you can get a lot more mileage out of your AI engineer with deliberate practice on evals and data. We usually find 4 to 6 weeks practice does the job. So in recap, one of the biggest failure modes is talent. We think that AI engineer is often overscoped but underspecified, but we can fix that by learning evals. Next, I want to give it over to Shrea, Shankar, and Eugene to dive into this evals and data literacy.
Thanks. Question. Thank you, Jason. Thank you, Hamo. Next up, Shrea and I are going to share with you about the tactical aspects of building with LLMs in production, specifically evals, monitoring, and guardrails. So here's a Hacker News quote. How important evals are to the team is a differentiator between teams shipping out hot garbage and those building real products. I would agree. I think here's an example of LLMs, of Apple's recent LLM, where they shared about how they actually collected 750 summaries of push notification and email summarizations, because these are data sets that are representative of their actual use case. So how do we build evals for our own products? Well, I think the simple thing is to just make it simpler. For example, if you're trying to extract product attributes from a product description, break it down into title, price, rating. And then you can just simply do assertions. Similarly, for summarization, instead of trying to eval that amorphous blob of a summary, break it down into dimensions, such as factual inconsistency, relevance, and informational density. And once you've done that, assertion-based tests can go a long way. Are we extracting the correct price? Are we extracting the correct title? Or if you're doing natural language to SQL generation, is it using the expected table? Is it using the expected columns? These are very simple to eval and reiterates what Hamo has mentioned about keeping it simple. Lastly, assertions can do everything, but they can only go so far. So therefore, consider evaluator models. Maybe training a classifier for factual inconsistency or reward model for relevance. This is easier if your evals are classification and regression based. But that said, I don't know how I feel about LLM as a judge. What do you mean you don't like LLM as a judge? I personally am super bullish on LLM as a judge, and I'm curious how many of you are exploring LLM as judge or have implemented it? No. Yeah? There's a judge right here. You want to stand up? No. Actual LLM judge here. Yeah. Anyways, we're going to go through some points on what to consider when deploying LLM as judge. First of all, it's no-brainer. LLM as judge is the most easy to prototype. You just have to write a prompt to check for the criteria or metric that you want, and you can even align this towards your own preferences by providing few-shot examples of good and bad for that criteria. On the other hand, fine-tuned models or LLMs that you have to collect a lot of data and set up a pipeline to train as your evaluator are not super easy to prototype and have a lot of upfront investment. Yeah, but that said, LLM as a judge is pretty difficult to align it to your specific criteria in the business. Who here has not had any difficulty aligning the LLM as a judge to your criteria? No. Anyone? Okay, we got to talk later, Shrea. I think that if you just have a few hundred to a few thousand samples, it's very easy to fine-tune a simple model who can do it more precisely. Second, if you want to do LLM as a judge and have it fairly precise, you sort of need to use chain of thought. And chain of thought is going to be, 5 to 8 seconds long. On the other hand, if you have a simple classifier or reward model every request is maybe 10 milliseconds long. That's 2 orders of magnitude lower and would improve throughput.
Next, we want to think about technical debt. Okay, when we're implementing our validators in production, even if they run asynchronously or they run in the critical path, how much effort do we need to put in to keep these up to date? With LLM as judge, if you don't make sure your few-shot examples are dynamic or some way of making sure your judge kind of prompt aligns with your definition of good and bad, then you're toast. And kind of the effect is not as pronounced for fine-tuned models, but if you don't continually fine-tune your validators on new data, on new production data, then they will also be susceptible to drift. So overall, when do you want to use LLM as judge? It's honestly a resources question and where you are in your application development. If you're starting to prototype it, you need quick evals with minimal dev effort and need something, you have a lowish volume of evals, start with LLM as a judge and kind of invest in the infrastructure to align that over time. If you have more resources or you know that your product is going to be sticky, go for a fine-tuned model. Next, I'm going to talk about looking at the data. Eugene mentioned, you should create evals on your custom or bespoke criteria, but how do you know what criteria you want? Simple answer, look at your data. Great AI researchers, but we changed that to engineers. Great AI engineers look at their data. So how do we do this? The first question actually before how is when do you look at this? I know people who never look at their data at all or people who look at it initially after deployment. Wrong answer. You want to look at it regularly. I work with a startup that whenever they ship a new LLM agent, they create a new Slack channel with all of the agent's outputs that come in real time. After a couple of weeks, they transition this to kind of daily batch jobs and make sure that they're not running into errors that they didn't anticipate. Second thing is, what specifically are you looking for? You want to find slices of the data that are pretty simple or easy to characterize in some way. For example, data that comes from a particular source, or data that has a certain keyword or phrase or is about a certain topic, right? Simply just saying all of these are bad, but having no way of characterizing them and then improving your pipeline based on that is not going to help. Finally, some things to keep in mind throughout this whole looking at your data experience is that your code base is very rapidly changing over time, probably. Your prompts, components of the pipeline, and et cetera. So when you're inspecting traces, it's super helpful to be able to know, what GitHub commit or what model version or prompt version did this correspond to. I think this is one of the very successful things that traditional MLOps tools did, like MLflow, for example. They made it very easy to trace back, and then hopefully you could replay something. Well, I see the judge shaking his head, but great. And finally, when using LLMs as APIs, pin model versions. LLM APIs are known to exhibit different behavior that is very hard to quantify for certain tasks. So pin GPT-4 1106, pin GPT-4o, whatever it is that you're using.
So Shrea mentioned that we need to look at our data, but how do we look at our data all the time? I think the way to do this is via an automated guardrail. Here's Brandolini's law adapted. The amount of energy to catch and fix defects is an order of magnitude larger than needed to produce it. And that's true. It's really easy to call an LLM API and just get something. But how do we know if it's actually bad? I think it's really important that we do have some basic form of guardrails, and some of them are just table stakes. Toxicity, personally identified information, copyright, and expected language. Now, you may imagine that this is pretty straightforward, but sometimes you don't actually have control over the context. For example, if someone's posting an ad on your English website that's in a different language, and you're asking your LLM to extract the attributes or to summarize it, you may be surprised that for some non-zero proportion of the time, it's actually in a different language. Similarly, hallucinations happen more often than we would like. So imagine you're trying to summarize a movie based on the description. You just have a description for the trailer. It may actually include spoilers because it's trying so hard to be helpful. But that's actually a bad user experience. So sometimes you will include information that's not in there. Here's a tip. If we spend a little bit more time building reference-free evals, we can use them as guardrails. So reference-based evals are when we generate some kind of output and we compare it to some ideal sample. This is pretty expensive, and you actually have to collect all these gold samples. On the other hand, if we have these labels, we can train an evaluator model, and just compare it to the source document. So for example, if you're comparing summarizations, we can just check if the summary entails or contradicts the source document. And now we have a summarization, a hallucination eval. So therefore, if we spend some time building reference-free evals once, we can use it to guardrail all new output.
Cool. Thanks, Eugene. So we're going to wrap up the next minute or so on some high-level, bird's-eye view, 2,000-foot view, whatever you want to call it, takeaways. First off, how many of you remember this figure from this pretty seminal paper in MLOps that came out maybe 10 years ago? 2015, so 9 years ago. Yeah. So I think this paper really communicated the idea that the model is a small part, and when you're productionizing ML systems, right, there's so much more around the model that you have to maintain over time. Data verification, feature engineering, monitoring, your infrastructure, et cetera. So you might be wondering, we have LLMs. Does any of this matter? Yeah? Yeah, seeing few nods here. Absolutely. When we have LLMs, all of these tech debt principles still apply. And you can even think of the exact mapping for every single component in here to the LLM equivalent. For example, maybe we don't have feature engineering pipelines, but cast it in new light, it's RAC. Right? We're looking at context, we're trying to retrieve what's relevant, engineer that to not distract the LLM too much. We have a ton of experimentation around that. All of this is something that needs to be maintained over time, especially as models change under the hood. Similarly, for data validation and verification, right, we have evals, we have guardrails that need to be deployed. Right? It's not just simply wrap your model or GPT in some software and ship it. No, there's a lot of investment that needs to happen around the model.
All right, so I'd like to end with this quote from Kapati senpai. There's a large class of problems that are really easy to imagine and build demos for, but it's extremely hard to build products out of. For example, Charles dug up this paper of the first car driven by a neural network. That was 1988. 25 years later, Andre Kapati took his first demo drive of Waymo, 2013. 10 years later, I hope all of you had a chance to try the Waymo. We got a driverless permit for Waymo in San Francisco. Maybe in a couple more years, we'll have it for the whole of California. The point is, going from demo to production takes time. So therefore, that's all we had. Thank you. Let's build. And now, I'm delighted and honored to welcome a very special guest, Thomas Domke. Thomas has been fascinated by software development since his childhood in Germany, and he's built a career building tools devs love and accelerating innovations that are changing software development. Currently, Thomas is CEO at GitHub, where he has overseen the launch of the first at-scale AI developer tool, GitHub Copilot. So please join me in welcoming to the stage, Thomas Domke. Thank you, Thomas.
Yeah. Ooh, it's bright out here.
Yeah. Well, thank you, everyone. Thank you, Thomas. Let's start with Copilot. Many people have shared their own takes on the Copilot origin story. So, but what was your personal experience seeing it in GitHub? I don't know, you had a sneak preview. Take us back to the start in 2020.
So imagine it's 2020. It's lockdown here in San Francisco and Seattle, everywhere where GitHub engineers are sitting. So like all of you probably were on a Zoom call. One of us had early access to a new model that OpenAI had just released in preview, a version of GPT-3 called Codex, and one had the Uge, I think, had the keyboard, the leader of GitHub Next at the time, and we were dictating prompts and asked the model to write some code. And I think the first aha moment that I had is that you could ask it to write JavaScript code and then put the curly braces in the right places and whatnot, and you could write it ask it to write Python code, and the model, in a way, you know, it doesn't work like a compiler. It doesn't have a syntax tree. It doesn't know these things. Or you could also argue it knows them exactly like we know it. So that was probably the first moment. We kept building, we kept exploring the model, and then decided we built this auto-completion copilot that, you know, was the first copilot, and we built it all, you know, while being remote, while being on lockdown. So if your investors tell you today you need to be in a room and in front of a whiteboard, you can innovate if you want to, while being in your home offices around the world. I think the next moment was that we shipped a preview to our internal engineers, and we call it a staff ship at GitHub. And the NPS survey with those engineers was through the roof. I think 72, 73, something like that. And typical our early stage products, especially, you know, with the large language model and, you know, all the hallucinations and the UI wasn't really figured out yet, is much lower. So that was kind of like a holy shit moment that we had. And as the product then shipped in mid-2021, and, you know, COVID was still going, we started looking at telemetry, and the team came and says it writes about 25% of the code in those files where it was enabled. And I remember saying, I don't believe this, like, your telemetry is wrong, please go back and validate that. And turned out, you know, that was actually right. And by now it's about half, you know, the code that's written. Some languages like Java even have a higher acceptance rate and more lines written. And so I think those this journey that we went through over the first 2 years really was like one moment after another, where we saw the future of AI long before ChatGPT actually opened everybody else's mind.
Amazing, and now it's available to everyone here as well. So I think Copilot started as an autocomplete in the IDE, and now it's all over GitHub. I know I have PR bots, etc. What do you do to make Copilot and integrate it across all of GitHub? Like, what are some experiments? What worked? What didn't work?
I think the first thing is to think about, you know, what do I do as a leader, as the CEO of a company, and it's really about constantly reconfiguring our approach. So much of, you know, the AI world is changing almost daily. There's, you know, some news on the information elsewhere every morning, and so there is no more I have a long-term strategy, I have my features all laid out and it's worked through the backlog. It's really like operating as agile as possible, even as we are, you know, 3,000 person company as part of, you know, one of the largest company on the planet. The second is that we really try to meet, you know, the developer where they are. We say, you know, we're not trying to build an AI engineer, we're trying to build AI for engineers, a human-centric approach. You know, that's where the name, what the name Copilot ultimately visualizes, but also, you know, we're trying to make the developers' lives better because we are developers ourselves, and every productivity improvement we can find ultimately helps us at GitHub to build, you know, our AI product. So that really is the approach, like looking at what can we do next to make, you know, our work a little bit easier of building more features for Copilot.
You mentioned a great point. You're trying to meet the developer where they are. So for now, we've been bringing the AI to the IDE.
Yeah.
Are we going to try to bring the developer, the IDE, closer to the AI? How are you thinking about that?
You know, the idea of bringing AI into the IDE, or really into ghost text, you know, auto-completions, was a way of getting around hallucinations. It was a way of saying, okay, the model is not always going to be perfect, but neither are auto-completions, right? Like, whether you have auto-completions in your Google Docs or in your email or in your editor in the old IntelliSense way, as you're typing, it cannot know what you wanted to type, and so you're used to adjusting your typing, and then you find this moment when you press the tab key. And even without auto-completions, if you think about what developers do in the editor, while they write code, and the best developers write a lot of code before they get stuck, and the newbies and those that rarely write code like I, you know, get stuck more often, and then you know, Control tab or Command tab into your browser, and you open Google or Stack Overflow, GitHub, right? And what you do there is you find code and you argue with other developers, and then you copy and paste that code into your editor, and you modify that as well. So it's kind of like, in a way, Stack Overflow has as many hallucinations as the model might have, and not because the answers are bad, but because the world is changing so much. You know, I code a little bit on iPhone projects in Swift, and there's always a new Swift version after WWDC or a new Xcode version, and so things have changed of how you use the APIs, and so it keeps the developer in the flow. That really the crucial thing here was we didn't, you know, in a world, 10 years ago, we probably wouldn't even call this AI. We would just call it, smarter auto-completion. And the AI piece is not the core piece. The core feature of Copilot is that it helps developers to stay in the flow to get the job done and not be in this constant distraction between the editor and the browser.
That's a great point. And I think a few months ago, you wrote this post about Workspace. What was the journey to creating Workspace? And maybe for folks who aren't unfamiliar with it, what is Workspace?
Yeah, so you already mentioned auto-completion. That's how we started in November 2022. ChatGPT happened, so early 2023 we added Chat and GPT-4 to Copilot in the IDE as a separate sidebar window. So you have that available, and it has RAG and all the information, the context available in the IDE. But ever since, we have been thinking, how can we make the developer flow even easier? And Workspace does exactly that. It takes a GitHub issue or just a task, an idea that you write down on github.com, and it helps you then, as part of your code base repositories, to figure out how to implement that change. It bridges from the issue, from the task description into the pull request, into the code. And the magic behind this is that the human is still in the center. So every step of that way, writing a specification, analyzing the current repo, the current behavior, and then using your description to figure out how do you modify this, then writing the plan, which shows you how to change all the files, to the implementation, which is the diff view, if you will. The human can interact, can change those bullet points, can change the code. And what that really does, it gives you a pair programmer that helps you to explore the code base, right? Because the challenge we all have as engineers is that as soon as you get moved onto a new project, or you want to modify an open source project, or you're just coming back from vacation, you're trying to remember what is implemented where in your 1,000+ files, that is navigating the code base is the first challenge you have, figuring out what's the current behavior and what's the new behavior. So you're having an AI native, a Copilot native developer environment that helps you along that journey that you're naturally also doing in your IDE. And that really is the key here. It's not about building an autonomous agent. I'm sure you have heard a lot about that in the last 3 days. It's about building agents that helps us as humans to solve a task and learn along the way as we figure out, there's this test file that I also have to modify if I want to implement this feature.
I love the point that you mentioned, which is not building autonomous agents and also helping the developers. So how should non-developers use Workspace?
They can, and in fact, once we announced this last year at GitHub Universe in November, I think the first email we got with feedback was from a program manager or product manager saying, this is awesome because now I can not only write a user story or a work item, I can also see what that would mean to implement in the code base. In many ways, the biggest challenge we have today is, can we be as specific as possible when we write down a task, as product managers or as engineers ourselves. Often everything is obvious until it is not. And then, you kind of need to size the task, right? Like, how long will it take? And the mythical man month, I think the pragmatic engineer had that a couple of weeks ago, is still true. Most estimates are half the time that the job actually takes. And so we're really bad at estimating how much time it takes to get work done, whether it's in coding or whether it's building houses or roads or infrastructure. And so Workspace helps you with that, as it helps you to figure out what I just described. Is it actually specific enough to write the code for that, or to even figure out what the plan would look like?
Can you share a bit about your vision on how you think we will build and code in natural language, and how it will help us collaborate better, devs and PMs, coders and non-coders, across languages and across the world?
For me, the very first thing when you say natural languages, and I have it on my t-shirt here, Copilot speaks your language, is because Chat, these large language models that we're using today in GitHub Copilot and many other AI applications, are the same models that are also helping us in chat agents. They speak almost any language, or any major human language. And so whether you want to explore coding in English and you don't understand the concepts of true, false, Boolean logic yet, or whether you want to learn that in German, in Hindi, in Brazilian Portuguese, in Spanish and Chinese, you can do that now. And if I look at kids today in school, most of them are growing up with mobile phones. When you go into a restaurant here in San Francisco or in Seattle or elsewhere in the world at night, you probably see a family with little kids where the kids have their phone because the parents want to enjoy 5 minutes on their own. And then as kids grow up, they see Super Mario or Minecraft, and they get into gaming, and that naturally then means, how can I create my own game? How can I create my own web page? Copilot enables that, and it enables that in the language that the kids grow up with, which for the majority of the humans on this planet is not English. And so that's number one. It democratizes access to technology. It also democratizes access for those that don't have parents at home that have a technical background, or that don't have parents at home that have infinite patience, which most parents do not. I have 2 kids. I speak from my own experience. At some point, you're just done, with explaining the world to your kids, and you just want to, switch on the TV and watch a Netflix show. But that keeps going. If you look into the professional context, one of the biggest challenges we have is, if you would join my company or I join your company tomorrow, the biggest challenge we have is what's all the institutional knowledge? How are things being done? And what we don't like as humans is ask 1,000 questions. Yep. Especially if you're a new employee in a big company, you're like having this anxiety in your head that everybody else thinks you're dumb. Why did you get hired in the first place? So a Copilot also democratizes access to all the information in companies, and I think that is going to be changing how we work, and not only for developers in the workforce, but for really every human.
Thank you, Thomas, for sharing your vision. I guess the next thing I want to ask is maybe a little bit more unhinged. Speaking of agents, in your opinion, what makes an agent or a Copilot? What's the definition? What's your definition of an agent?
I think an agent, is like an AI dishwasher. You fill it with, the dishes, and you let it do its thing, and then at the end you take the output and you put it back into the shelves, right? And today we have, used to call it bots, or CI/CD in many ways. That's an autonomous agent, right? You push your pull request and you run your CI/CD GitHub Actions or a similar product. Many compute primitives that we have today are agents as they get a job done on their own. My monitoring, to figure out if GitHub up or down is somewhat autonomous. Hopefully it pages somebody without us hearing from you that you cannot access your repository. So, I think in many ways, what we are building is still tools that help us to get the job done. And there's many jobs that developers have to get done, many jobs that now AI engineers need to get done. You saw it on the slide earlier, all the things that are also still true, even though you can automate things with large language models. And a lot of work in software engineering is bogging us down. A lot of boilerplate, a lot of security compliance. That Friday evening when you want to enjoy the barbecue because the sun is out, and instead you have to update all your Log4j dependencies, right? Like security tooling, in fact, is creating more work. It's not a dishwasher. It's actually a tool that shows you tells you that the dishes are dirty, and then you have to do the dishes yourself today. And so that's security tooling, right? It just adds stuff to our backlog while we actually want to work on the creative side, and we want to build new features. We want to build innovative product that creative things. I think many software developers do not understand themselves as a production worker. They understand themselves as artists, as creators.
Yes.
But our companies, our governments, the world is requiring us to do a lot of other work, and we need AI tools. Autofix, things that scans not only for security issues, but then fixes those security issues. We need those pieces supported by AI, so we have more time for the things we do want to do, and AI takes over the things we don't want to do, and that's where the agents will go.
Fantastic. What's an agent you want to have, and how far are we from it?
I mean, I want to have these agents that burns down all my security backlog. It's as in any company, the challenge is that I have way too many of these items, and there isn't really a book you can buy that tells you as an engineering manager of how to balance those two things. You cannot do all your work into security compliance, accessibility and whatnot, and you cannot put all your work into innovation because your customers will lose all your trust the moment you have a security issue that threatens their data. And as such, you have to balance those two things, or you find AI agents that brings the work down. And I think as any leader of a software development company, I always want to go faster. I always want to get that feature done faster, and I'm sure it's the same for you folks at Amazon. When I have an idea and I ask my folks how long will it take to implement that, the estimate I'm getting is like I'm scratching my head and I'm thinking I can do that myself faster than waiting for my team to do it. But of course that's not the truth. The truth is that there's so many other things in the process these days that we need to find new abstraction layers that help us to get control over our development lifecycle again.
That's a great point. So last question. Do you have any advice for devs, both new and experienced, on how they should navigate this new world of tools, this new world of abstractions, in what some say is the biggest technology innovation since the internet?
I think the most exciting thing about this new technology is, and you saw it hopefully over the last 3 days at this conference, is that we are moving into a new world of software development. And there have been multiple step functions over my life. I was born right before the PC was invented. I remember getting my Commodore 64 on a PC in the 90s. I remember the open source and the internet. And internet open source before the internet was buying CDs and DVDs in bookstores. The internet came, SourceForge, and then GitHub came. All of a sudden, developers started collaborating. The mobile wave came, and every time we had those step functions, software development got more exciting. And I think we are again at that step function. It means we can embrace our nerditude. We can build new shit. And yes. I think it's really like for me as the CEO of GitHub, I don't get to touch code often. And so when I get to touch code on a Sunday afternoon, I don't want to spend all my time of updating all my dependencies, and I don't want to figure out all the things that have changed in the API documentation, or how to deploy the container to the cloud now, and what has, there's so many things changing around us that we want to bring the fun back. And I think it's AI brings the fun back into software development. And so I want to encourage you all, go back home and build some cool stuff and embrace this new world of AI.
Okay, that's all we had. Thank you, Thomas. Please join me.
Thank you so much.
Ladies and gentlemen, please welcome back to the stage your host and co-founder of the AI Engineer Summit, Benjamin Dunphy.
Oh my God. How are we feeling? Better than me, I hope. I'm exhausted. What a way to end an event. Open AI, rapid fire talks from legends, and the CEO of GitHub. Can we have a round of applause for our final keynote speakers? Incredible. I think the only thing left to say is thank you. Thank you all for coming to this event. We can put together the best flows, content, productions, but it means nothing without all of you. The community members who show up and learn, engage, and connect. So we thank you for that. So please give yourself a round of applause. Next, I want to thank Microsoft. They were a sponsor of Summit last October, and Britton Winterrose in particular was our first champion, as I recall, for taking their sponsorship up a notch. So thanks to him, and I couldn't be happier with their partnership. Sharon, Allison, Kayla, you've all been just absolutely incredible to work with, and special thanks to all the speakers from Microsoft and GitHub for your hard work and incredible content. AWS, I've been a user and fan of this company for some time, and as someone who produces events, I'm in absolute awe of what they do for reInvent and all the other events that they do. And Memo, you are just incredible. Keep doing what you're doing. And Auntie, I'm so excited to hear that you're turning San Francisco's AWS Loft into an AI engineering meetup hub. You announced that at your keynote. It's incredible. San Francisco is back, baby. MongoDB, Google, Neo4j, you all brought your A game. Thanks for your partnership and support from the planning and organizational side to the content and production side, to all of our other sponsors, especially our gold and silver sponsors. You not only help to make the event a financial success, you make every aspect of this event more interesting, engaging, and valuable. This event is enriched by your presence, and we thank you for being here. Argus HD, Seriously, Argus HD. You never cease to amaze me. Tim, Ryan, Tim, the other Tim, everyone else. You guys are incredible. Our budget is small, but you all make it work, and they did all the breakouts. It's just absolutely incredible. You put on an incredible show. Motif Events. Do you guys see that expo? That's Motif Events. They designed and built that. We selected them not only because they were the most innovative, but because it was clear to me that they put in the most work and heart into what they do. So thanks Dave, Ben, and everyone else, and thanks to the entire Local 16 crew for your excellent craftsmanship in assembling and disassembling. This thing had to come down between the sessions. We brought the air wall in. Y'all saw that. They did that super, super fast. So thank you all for that. Everyone at the Marriott Marquis, you've all just been absolutely incredible. Food was good. Coffee was good. Everyone's super responsive. Internet good, at least as far as I was concerned. Hopefully y'all were as well. All of the speakers. We can't have an event without the speakers. They work incredibly hard on these talks. Like Picasso, it took them their entire lives to create that talk. But unlike Picasso, it takes weeks or even months to accomplish. So to all of our speakers, thank you so much for being an incredible part of this event. Cody and VideoTap for managing our live stream with real-time clips of our YouTube live stream. So thank you, Chris, Otto, everyone at SourceCraft, everyone at Cody for helping with the distribution of this incredible content for a wider audience. And volunteers. These are the folks in the yellow staff t-shirts. They are not paid, they're volunteers. Events are super expensive and we can't do it without you, so we thank you so much. And Leah McBride, many of you met her at registration and she's an absolute force. Seriously, she's an entire agency at the event. So I'd like you to welcome her to the stage. If we could all just show our gratitude with a round of applause. And Leah, we will get you some more on-site support for next year, so you're gonna be working a little less hard. Simon Sturmer is a beast of an engineer and volunteers so much of his time to help with the conference website and mobile app. This, of course, has bugs. We have volunteers running this shit. If you guys want to contribute and build some cool stuff that we're doing, email me directly, ben@ai.engineer. We could use some help. Lastly, Swix. Seriously, you all don't know how much heart and soul and sweat and time this man has put into this event. I'm beyond disappointed that he missed this event, but he is watching from the live stream, so can we show some love for Swix? Max Video Productions, who handles our B-roll cinematography and speaker interviews. Randall Gee, who does our photography. Angeli Fish for live voiceovers. Sasha Sheng, who helped with the diversity committee. Everyone from the diversity committee. Sarah Chiang, Tony True, Harper Carroll. So many people. If I forgot you, I'm sorry. I put this together 5 minutes before I went on stage. Crazy times. But thank you all so much for being here. Thank you for coming. And we will see you next year. Don't forget to secure your ticket today. Bye-bye. Thank you, everyone.
Holding my breath and I'm ready to go. I'm fine.